Welcome! You have found your way to this quiet hour. As you settle in, let the day's demands fade. Let your thoughts slow one by one. Tonight we are going to follow Roman soldiers far from home, not in battle, not on the march, but in the hours after sunset when the temperature dropped and the wind turned sharp, and survival depended on wool, leather, and the warmth of 7 other men sleeping close beside you. For centuries, Rome's armies campaigned in places that had never known Mediterranean sun. The Rhine frontier, the Danube, the hills below Hadrian's Wall. In these regions, winter was not a season, but a test. Temperatures fell well below freezing. Daylight lasted only a few hours, and every night thousands of soldiers had to rest in temporary camps with no permanent shelter, no stone walls, no heated rooms. How did they manage this? How did they sleep without freezing? Their methods were practical, refined over generations of hard experience. They relied on careful construction, layered clothing, and a disciplined understanding of heat and cold. There was no single innovation. It was a system of small, essential acts working together. Over the next while, we will move through one winter night on the frontier. We will see how soldiers transformed open ground into shelter as darkness fell. We will follow them to their low-leather tents. We will understand the layers they wore, the ground they prepared, and the discipline that kept them alive until morning. So settle in. Let the story unfold at its own pace. The army halts in the late afternoon. The signal passes down the column, and thousands of men slow to a stop. They have been walking since first light, covering perhaps 15 miles through cold, uneven terrain. Now the landscape around them is empty. Open fields, low hills, bare trees, no walls, no buildings, just earth and sky and the wind coming steady from the north. This moment is vulnerable. The soldiers are tired, the temperature is dropping. In a few hours it will be fully dark and the cold will deepen. But for now they are standing in the open with no protection. The transition from march to rest begins immediately. There is no pause, no waiting. The instant the halt is called, the army shifts into a different rhythm. Officers move to their positions. Engineers step forward with their tools. Soldiers drop their packs and begin pulling out stakes, shovels, and measuring cords. They have done this hundreds of times. The process is automatic. Every man knows his role. Every contubernium, each squad of 8 soldiers, knows where they will sleep, where their tent will stand, and what work must be completed before nightfall. The first task is not rest. It is security. And security on the winter frontier means creating a barrier between the soldiers and everything outside. The cold, the wind, the possibility of attack, all of it must be addressed before anyone can lie down. The engineers move quickly across the ground, marking out the camp's perimeter. They use a tool called a groma, a wooden cross with weights hanging from cords to ensure perfect right angles. The camp will be rectangular. It will have 4 gates, 1 on each side. The layout will match every other camp they have built, from Gaul to Germania to Britannia. This repetition is intentional. When a soldier walks into camp, even in unfamiliar territory, he knows exactly where he is. The command tents are always in the centre. The main roads run north-south and east-west. The contubernium tents are arranged in neat rows. The latrines are always in the same corner. The gates open in the same directions. This geometric order does something important. It transforms a hostile, unknown place into a Roman space. The soldiers are no longer standing in foreign wilderness. They are standing inside a structured, predictable environment that they understand completely. The layout is so familiar that even in darkness, even exhausted, they can navigate without confusion. The psychological effect is subtle but real. Anxiety decreases when surroundings are predictable. The mind settles when it recognizes patterns. By imposing this rigid, repeating blueprint onto the landscape, the army creates a sense of control. And control, even the illusion of it, makes rest possible. But the blueprint is only the beginning. Now the real work starts. The soldiers form into work parties. Some begin digging the perimeter trench. Others gather the wooden stakes they have been carrying. Still others start hauling soil. The entire camp must be fortified before anyone sleeps. The digging begins at the marked line. The trench, called the fossa, will encircle the entire camp. It does not need to be deep, usually about 3 feet, but it must be continuous. no gaps, no weak points. The soldiers work quickly, moving along the perimeter in coordinated teams. As they dig, they throw the excavated soil inwards toward the centre of the camp. This creates a raised mound called the agger. The earth piles up row after row until it forms a substantial barrier. The height varies depending on the threat level and the time available, but even a modest rampart stands several feet tall. Once the soil is in place, the soldiers drive wooden stakes into the top of the mound. These stakes, called valli, are sharpened at one end and planted close together, forming a palisade. Each soldier carries 2 or 3 stakes as part of his standard equipment. When thousands of men contribute their stakes, the result is a continuous wooden fence running along the entire perimeter. The effect is immediate. What was open ground is now enclosed. The camp has a defined boundary. Anyone approaching from outside must cross the trench, climb the rampart and breach the palisade. It is not a permanent fortification, but it is enough to delay an attacker and give the sentries time to raise the alarm. But the defensive function is only part of the purpose. The rampart does something else, something essential for survival in winter. It blocks the wind. On the northern frontier, wind is a constant presence. It comes off the plains, across the rivers, down from the hills. It is cold, cutting, relentless. Without a barrier, it sweeps through an open camp, stripping away any warmth the soldiers might generate. A fire burns less efficiently. Wet clothing does not dry. Body heat dissipates into the air. The wind makes everything colder. The agger changes this. By raising a solid earthen wall around the camp, the soldiers create a sheltered zone in the interior. The wind no longer moves freely through the camp. Instead, it is forced to rise up and over the rampart, passing above the low leather tents that will soon fill the space below. This is not a complete elimination of the wind. Air still moves inside the camp, but the velocity decreases. The constant battering stops. The temperature inside the perimeter is measurably higher than the temperature outside. The difference might only be a few degrees, but in freezing conditions, a few degrees matter. The soldiers are not thinking in terms of thermal dynamics. They are not calculating wind chill or convective heat loss, but they understand from experience that a camp with a good rampart is warmer than a camp without one, and warmth, even a small amount, makes sleep possible. The construction continues as the light fades. There is no rushing, but there is also no wasted motion. Every action has been practiced. Every tool is used efficiently. The work is hard, but it is familiar. And because it is familiar, it can be completed quickly. By the time the trench is finished and the stakes are in place, the sun is low on the horizon. The camp is secure. The perimeter is defined. The wind is partially blocked. Now the focus shifts. Firewood. With the defences complete, the remaining daylight is dedicated to gathering fuel. Soldiers move out beyond the rampart in organised groups, searching for dry wood. Branches, deadfall, anything that will burn. They bring it back in armloads, stacking it in designated areas inside the camp. The wood is not for heating the tents. That is not possible, not safely. But it is essential for cooking, for boiling water, and for maintaining small fires in controlled areas where men can warm their hands or dry wet clothing. The fires will burn in the open in fire pits dug into the ground under supervision. The ability to gather fuel depends entirely on having completed the fortifications first. If the camp were not secure, soldiers could not leave the perimeter without risk. The defensive work must come first. Only then can the army afford to send men out to collect the resources needed for basic comfort. This is Roman logistical discipline. Defence, then warmth. Security, then sustenance. The order never changes. As darkness approaches, the camp settles into its nightly form, the rampart stands solid, the gates are positioned and guarded, the interior roads are clear. The contubernium plots are marked out, each one assigned to a specific squad. The soldiers know where they will sleep. They know what comes next. The march has ended. The ground has been transformed. The vulnerable moment has passed. Now they must prepare to survive the night. The layout of a Roman marching camp follows a pattern that does not change. Whether the army halts in Gaul, Germania, Britannia, or along the Danube, the result is the same: a rectangle, 4 gates, 2 main roads intersecting at the centre, rows of tents arranged in precise blocks. This consistency is not accidental. It is the result of written doctrine, passed down through military manuals and reinforced by generations of practice. One such manual, the De Munitionibus Castrorum, outlines the principles in careful detail. The dimensions, the spacing, the placement of command tents, the location of supply stores, everything is specified. The engineers responsible for laying out the camp are called mensors. They arrive with the advance party, sometimes hours before the main column. Their job is to select suitable ground and mark the perimeter before the bulk of the army reaches the site. The selection of ground follows clear criteria. The site must be level enough for construction, but elevated enough to avoid flooding. It must be near a water source, but not so close that the camp is vulnerable to ambush from the riverbank. It must have clear sight lines in all directions, and it must be large enough to accommodate the entire force. Once the site is chosen, the mensors use the groma to establish the camp's orientation. The tool is simple but effective. A vertical pole supports a horizontal crosspiece. 4 weighted cords hang from the ends of the crosspiece, forming perfect right angles. By sighting along these cords, the engineers can mark out straight lines and ensure that the camp's corners are true. The first line marked is the Via Principalis, the main road running east to west. The second is the Via Praetoria, running north to south. These 2 roads divide the camp into quadrants. At their intersection stands the command area, where the general's tent and the senior officers' quarters will be placed. From these central roads, the engineers mark out the smaller streets and the individual tent plots. Each contubernium is assigned a specific location, identified by century and cohort. When the main column arrives, the men do not need to ask where to go. They already know. The layout is identical to the camp they built the night before and the night before that. This repetition serves a function that goes beyond logistics. It creates familiarity in an unfamiliar world. A soldier on campaign is always in foreign territory. The landscape changes daily. The weather is unpredictable. Threats are unknown. Everything outside the camp is variable, unstable, potentially hostile. But inside the camp, everything is constant. The soldier knows that his tent will always be in the same position relative to the Via Principalis. He knows that the latrines will always be in the far corner. He knows that the supply depot will always be near the east gate. He knows that if he needs to find his centurion, he should go to the command area in the centre. This knowledge is automatic, it does not require thought, and because it does not require thought, it conserves mental energy. The soldier is already tired from the march, he is cold, he is hungry, he does not have the capacities to navigate a chaotic, disorganised camp. The geometric order removes that burden. The effect is calming. The mind recognises the pattern and relaxes. The camp becomes a place of order in the middle of disorder. And order in a hostile environment is a form of safety. The psychological function of the blueprint extends beyond individual comfort. It also reinforces unit cohesion. Because every soldier knows the layout, communication is faster. Orders can be given without lengthy explanations. If a messenger needs to find a specific sentry, he knows exactly where to go. If an alarm is raised, every man knows the quickest route to his assigned position on the rampart. The camp is not just a place to sleep. It is a machine designed for efficiency, and the blueprint is the instruction manual that makes the machine work. As the soldiers arrive at their assigned plots, they begin the next phase of preparation. The ground has been marked, the perimeter has been secured, now they must raise their individual shelters. Each contubernium unpacks its equipment. The tent, the poles, the stakes, the ropes. Everything has been carried on the back of a single mule, which also hauls the squad's hand mill for grinding grain and the shared cooking pot. The mule is the squad's most valuable asset, and its welfare is a constant concern. The tent itself is a heavy bundle. When dry, it weighs approximately 43 kilograms. When wet, it weighs even more. The soldiers unfold it carefully, spreading the leather panels on the ground. The material is thick, made from goatskin sewn into squared patches. The edges show signs of repeated repair. Torn sections have been patched. Weak seams have been restitched. The tent has been in service for years, and it will remain in service until it falls apart completely. The soldiers have done this hundreds of times. They do not need to speak. One man holds the ridgepole, 2 others lift the supporting poles into position. The rest stretch the leather over the frame, securing the edges with wooden stakes driven into the ground. Guy ropes are tied and tensioned. The process takes perhaps 10 minutes. When finished, the tent stands low and compact. The ridgeline reaches about 2.2 meters at its highest point. The footprint is roughly 3 meters by 3 meters. The shape is simple. 2 sloping sides meet at a central ridge. There are no windows. The entrance is a flap that can be tied shut. From the outside, the tent looks small, and it is small. But that smallness is intentional. The interior volume is limited. There is not much air inside, and because there is not much air, the air can be warmed. 8 men lying close together generate heat. If that heat were released into a large space, it would dissipate. But in a confined space, it accumulates. The tent is not designed for comfort. It is designed for thermal efficiency. The low ceiling, the tight walls, the minimal volume, all of it serves the same purpose: to trap heat, to create a microclimate, to make survival possible when the temperature outside drops below freezing. The soldiers understand this. They do not complain about the cramped conditions. They know that the alternative, sleeping in the open, is not viable. The tent, small as it is the difference between life and death. Once the tent is raised, the soldiers begin arranging the interior. There is not much space, but what space exists must be organised. Shields are stacked near the entrance. Armour is placed along the walls. Packs are pushed to the edges. The centre of the tent is left clear. That is where the men will sleep. The organisation is methodical. Everything has a place, nothing is left loose. In the morning, when the tent is packed again, every item must be found quickly and loaded onto the mule. Disorder wastes time. Time wasted in the morning means a late start. A late start means fewer miles covered. Fewer miles means the campaign takes longer. Everything connects. As the soldiers work, the light continues to fade. The camp is now filled with rows of identical tents. Hundreds of them, thousands depending on the size of the force. From above, the camp would look like a grid, perfectly aligned, perfectly symmetrical, a geometric imposition on the natural landscape. The fires are lit. Small flames appear throughout the camp, concentrated in designated areas. The smell of wood smoke spreads. Soldiers gather near the fires to cook their evening rations. Grain is ground, water is boiled, simple meals are prepared. The fires provide warmth, but only to those standing directly beside them. The heat does not carry far. The soldiers eat quickly. There is no lingering. The temperature is dropping fast now. The wind, though partially blocked by the rampart, still moves through the camp. Wet clothing does not dry. Fingers grow numb. The warmth from the fires is temporary, fleeting. After the meal, the soldiers return to their tents. The fires are banked. Guards take their positions on the rampart. The camp settles into its nightly routine. Inside the tents, the final preparations begin. The soldiers remove their wet outer layers and hang them near the entrance. They check their wool tunics, adjusting layers. They inspect the ground beneath the tent, making sure it is as dry as possible. And then, as full darkness arrives, they lie down. The blueprint has been repeated. The camp is secure. The night can begin. The work of digging the perimeter trench begins immediately after the camp layout is marked. There is no delay. The soldiers drop their packs, take up their tools, and move to their assigned sections of the line. Each man carries a delabra, a versatile tool that combines a pickaxe blade on one side and an adze on the other. It is heavy, well-balanced, designed for breaking ground. The soldiers have been using this tool since their first days of training. They know its weight, its leverage, its capabilities. The ground they are digging into varies. Sometimes it is soft loam, easy to penetrate. Sometimes it is clay, dense and sticky. Sometimes it is frozen, requiring repeated strikes to crack the surface. In the worst conditions, the soldiers must use fire to soften the earth before they can dig. But regardless of the ground's resistance, the trench must be completed. The standard depth is approximately 1 metre. The width is similar. These dimensions are not arbitrary. They are calculated to provide a meaningful obstacle. A trench 1 metre deep cannot be easily crossed at a run. An attacker must slow down, descend into the trench, and then climb out the other side. This delay gives the defenders time to react. But the trench is not only a defensive feature, it is also the source of the rampart. As the soldiers dig, they throw the excavated soil inward, toward the centre of the camp. The earth piles up along the inner edge of the trench, forming a raised mound. The soldiers do not scatter the soil randomly. They pack it down, shaping it into a solid, sloped barrier. The outer face of the mound is steep. The inner face is more gradual, allowing soldiers to walk up and down easily. The process is loud, the sound of metal striking earth, the scrape of shovels, the grunt of effort. Hundreds of men working simultaneously create a steady, rhythmic noise that fills the camp. It is the sound of construction, of transformation. The landscape is being reshaped by human labour. As the rampart grows, its function becomes visible. The mound rises above the level of the surrounding plain. It creates a physical barrier between the interior of the camp and the exterior. Anyone standing outside the camp now sees an earthen wall instead of open ground. Anyone standing inside sees a protective berm. The height of the rampart varies depending on the perceived threat and the time available. In hostile territory, the soldiers build it higher. In relatively safe areas, a lower rampart suffices, but even a modest rampart 2 or 3 feet tall provides meaningful protection. Once the rampart is shaped, the soldiers plant the wooden stakes. These stakes are carried by every legionary as part of his standard equipment. They are called valli, and each man typically carries 2. The stakes are approximately 5 feet long, sharpened at one end, sometimes tipped with iron. The soldiers drive the stakes into the top of the rampart, angling them outward. The stakes are placed close together, forming a continuous palisade. The result is a wooden fence that runs the entire length of the perimeter. The fence is not tall, but it is solid. It cannot be easily pulled down or breached. The combination of trench, rampart and palisade creates a layered defence. An attacker must first cross the trench, then climb the rampart, then get past the stakes. Each layer slows the attack, giving the defenders more time to respond. But the defensive value is only part of the story. The rampart serves another function, one that is just as important for survival on the winter frontier. It blocks the wind. Wind is a constant presence in the northern provinces. It comes off the North Sea, across the German plains, down from the Scottish Highlands. It is cold, persistent and physically draining. Prolonged exposure to wind accelerates heat loss from the body. Wet clothing dries more slowly. Fires burn less efficiently. The subjective experience of cold intensifies. The Romans do not have a scientific understanding of wind chill, but they understand its effects. They know that a sheltered position is warmer than an exposed one. They know that a barrier reduces the force of the wind. And they know that reducing the wind's force makes the camp more habitable. The rampart functions as a large-scale windbreak. When the wind encounters the earthen wall, it is forced upward. The air rises over the top of the rampart and continues moving across the camp at a higher elevation. The tents, which stand only 2 meters tall, are positioned below the main flow of the wind. This creates a sheltered microclimate inside the camp. The wind speed at ground level is significantly lower than the wind speed outside the perimeter. The temperature inside the camp is measurably higher. The difference might only be 2 or 3 degrees Celsius, but in freezing conditions that difference is meaningful. The soldiers are aware of this effect, even if they do not articulate it in scientific terms. They know that a well-constructed rampart makes the camp warmer. They know that the time spent digging is time invested in their own survival. The work continues as the light fades. The trench deepens. The rampart grows. The stakes are driven in. The soldiers move along the perimeter in coordinated teams, each team responsible for a section of the line. There is no supervision required. The work is self-organising. Every man knows what needs to be done. The physical effort is considerable. Digging is hard labour. The soldiers are already tired from the day's march. Their muscles ache. Their hands are cold, but they do not stop. They cannot stop. The perimeter must be completed before nightfall. This is where the discipline of the Roman military system becomes visible. The soldiers do not work because they are individually motivated. They work because the system requires it. The camp cannot function without a secure perimeter. The perimeter cannot be secured without labour. Therefore, the labour is performed. There is no debate, no negotiation, no consideration of personal comfort. The task is assigned. The task is completed. This is the basic logic of military organisation, applied consistently across thousands of campaigns. As the trench nears completion, the soldiers begin to shift their focus. Some continue working on the remaining sections of the perimeter. Others move to the next task, gathering firewood. The ability to send men out to collect fuel depends entirely on having a secure perimeter. If the camp were not fortified, soldiers leaving the perimeter would be vulnerable to attack. They would need to be escorted by armed guards. The process would be slow and dangerous, but with the rampart in place and the gates positioned, the camp is defensible. Small parties can leave through the gates, gather wood in the surrounding area, and return safely. The defensive work makes the logistical work possible. The soldiers move out in groups of 10 or 12 carrying axes and ropes. They spread out across the nearby terrain searching for dry wood. Deadfall is preferred. Standing dead trees are also good. Green wood is avoided. It does not burn well and produces too much smoke. The wood is cut into manageable lengths and bundled. The soldiers carry it back to the camp in armloads, stacking it in designated areas near the gates. The piles grow steadily. By the time full darkness arrives, the camp has enough fuel for the night's cooking fires and a reserve for the morning. The fires themselves will be lit in controlled areas, not inside the tents, not scattered randomly throughout the camp. Fire is dangerous. It must be managed. The soldiers light small fire pits dug into the ground, surrounded by stones to contain the flames. These fires serve multiple purposes. They provide heat for cooking. They allow soldiers to warm their hands. They offer a small amount of light in the darkness, but they do not provide enough heat to warm the entire camp. The fires are localized. Their warmth extends only a few feet. For general warmth, for the warmth needed to survive the night, the soldiers must rely on other methods. The rampart, the tent, the layers of wool, the proximity of other bodies. The fires are a supplement, not a solution. As the perimeter work concludes, the camp transforms. What was an open, vulnerable position is now an enclosed, defensible space. The trench encircles the perimeter. The rampart stands solid. The palisade bristles with stakes. The gates are in place, guarded by sentries. The wind no longer moves freely through the camp. It rises over the rampart, leaving the interior relatively calm. The temperature inside the perimeter is higher than the temperature outside. The soldiers have completed the first essential task. They have created a barrier between themselves and the elements. The ground has been reshaped. The landscape has been transformed. Now they can focus on the second task, preparing to sleep. The rampart, once completed, changes the character of the camp. What was an open field exposed to the full force of the northern wind is now a partially sheltered enclosure. The transformation is not dramatic, but it is real. The soldiers do not fully understand the physics of convective heat transfer, but they understand the result. A camp with a good rampart is warmer than a camp without one. The wind, instead of cutting through the rows of tents, is deflected upward and over the perimeter. The air inside the camp is calmer. The difference is not absolute. Wind still moves through the camp. Air currents still circulate. But the velocity decreases. The constant battering stops. The soldiers standing inside the perimeter can feel the change. Their clothing flaps less. Their breath does not get torn away as quickly. The cold is still present, but it is less aggressive. The rampart functions as a large-scale barrier, but its effectiveness depends on several factors: the height of the mound, the angle of the slope, the solidity of the packed earth. A hastily constructed rampart, thin and unstable, provides minimal protection. A well-built rampart, thick and tall, creates a meaningful thermal boundary. The soldiers know this from experience. They have built hundreds of camps. They have slept in well-protected camps and poorly protected camps. They know which conditions lead to a tolerable night and which conditions lead to suffering. When time allows, they build the rampart higher. They pack the earth more carefully. They ensure that the palisade is secure. These small improvements accumulate. The camp becomes incrementally warmer, incrementally more survivable. The positioning of the tents also matters. The papilio is placed in the sheltered zone behind the rampart, not directly in line with the gates. The gates are necessary for movement, but they create gaps in the windbreak. Air flows through these gaps, creating drafts in the interior. The soldiers avoid pitching their tents in the direct path of these drafts. They position the tents in the rows designated by the camp layout, but within those rows, they choose spots that are maximally sheltered. A position behind the rampart, away from the gates, out of the main wind channel. This attention to micro-topography is learned behaviour. New recruits do not think about it. They pitch their tent wherever they are told, but veterans know. They look at the landscape, they assess the wind's direction, they make small adjustments. A tent placed 1 meter to the left or right can be noticeably warmer. The rampart also affects sound. Wind carries noise. In an exposed position, voices travel unpredictably. Shouted orders are lost in the gusts, communication becomes difficult. But behind the rampart, sound behaves more predictably. Voices carry more clearly. The camp becomes quieter. This quietness is not complete silence. The camp is full of activity. Soldiers are moving, equipment is being unpacked, fires are being lit, commands are being given. But the background roar of the wind is reduced. The acoustic environment is less chaotic. For soldiers trying to rest, this reduction in noise matters. Sleep is difficult in a constantly noisy environment. The brain remains alert, processing every sound, unable to fully relax. But in a quieter environment, sleep becomes possible. The rampart then serves multiple functions. It provides defense against attack. It reduces wind speed. It lowers ambient noise. It creates a psychological boundary between the camp and the wilderness outside. All of these functions contribute to the camp's habitability. The soldiers do not articulate these functions in technical terms. They do not discuss thermal dynamics or acoustic dampening. But they understand in a practical, embodied way that the rampart is essential. They understand that the time spent digging is time well spent. As the rampart nears completion and the camp settles into its nightly form, the soldiers begin to focus inward. The external defences are in place, the perimeter is secure. Now the attention shifts to the individual squad, the contubernium, and the small leather tent that will be home for the night. The papilio's already standing, the poles are in place. The guy ropes are tensioned. The entrance flap is tied back, allowing access. The interior is dim, lit only by the fading daylight filtering through the leather. The soldiers gather at the entrance of their tent. 8 men. They are tired. Their clothing is damp from sweat and melting snow. Their hands are cold. They have been working since dawn, first marching, then constructing the camp. Now, finally, they can stop moving. But stopping does not mean resting, not yet. There is still work to be done. The tent must be prepared. The ground must be checked. The sleeping arrangements must be organised. The transition from activity to rest is not immediate. It is a process. One soldier enters the tent first, crouching to avoid the low ceiling. He inspects the ground. Is it level? Are there rocks or roots that need to be removed? Is the earth damp? If the ground is wet, it will drain heat from the body through conduction. Wet ground is dangerous. If the ground is problematic, the soldiers make adjustments. They scrape away the top layer of soil. They spread straw or brushwood to create an insulating layer. They do not have mattresses. They do not have wooden platforms. But they have knowledge. They understand that placing a barrier between their bodies and the frozen earth is essential. The straw, if available, is spread evenly across the floor of the tent. It is not thick. There is not enough material for a deep layer. But even a thin layer of straw provides some insulation. It prevents direct contact between the body and the ground. It traps small pockets of air, which resist heat transfer. In areas where straw is not available, the soldiers use whatever they can find: pine boughs, dried, grass, leaves, anything that creates separation from the earth. The principle is always the same: minimize conductive heat loss. This knowledge is not written in manuals, it is not taught in formal training. It is learned through experience, passed down from veterans to recruits through observation and imitation. A new soldier watches the veterans prepare the ground. He sees what they do. He does the same. Over time, the practice becomes automatic. Once the ground is prepared, the soldiers begin arranging their equipment. Shields are propped against the tent walls. Armour is stacked near the entrance. Packs are pushed to the sides. The goal is to create as much clear floor space as possible in the centre of the tent. This space, roughly 2 meters by 2 meters, is where the 8 men will sleep. It is not large. Each man will have approximately half a square metre of personal space. There is no room to stretch out, no room to move freely. The soldiers will be lying shoulder to shoulder, pressed together. This density is not accidental. It is the core of the survival strategy. 8 men lying close together generate heat. Each body produces thermal energy as a byproduct of metabolism. In an open space, this heat dissipates into the surrounding air, but in a confined space, the heat accumulates. The air inside the tent warms, the temperature rises. The tent's small volume amplifies this effect. There is not much air inside, perhaps 15 cubic meters. The heat generated by 8 bodies can raise the temperature of this small volume by several degrees. The change is measurable. More importantly, it is perceptible. The soldiers feel the difference. Inside the tent, the air is warmer than the air outside. Not warm, but warmer. Warmer enough to make sleep possible. The low ceiling of the tent also contributes to this thermal efficiency. Warm air rises. In a tall structure, warm air accumulates near the ceiling, far from the bodies below. But in a tent with a ridgeline height of only 2.2 meters, the warm air cannot rise far. It remains close to the soldiers. The tent then is not just a shelter, it is a thermal container. It traps the heat generated by the occupants and prevents it from escaping into the cold night air. The leather walls provide insulation. The low volume minimizes the amount of air that needs to be warmed. The confined space forces the soldiers into close proximity, maximizing heat exchange. This system works, but it requires discipline. The soldiers must accept the discomfort of confinement. They must tolerate the lack of privacy. They must lie still, pressed against their comrades, for hours. There is no alternative. Sleeping outside the tent is not viable. Sleeping alone is not viable. The only way to survive the night is to share warmth. The contubernium is not just a military unit, it is a thermal collective. As the soldiers settle into the tent, the last light fades from the sky. The camp is now fully dark. Fires burn in scattered locations, small points of orange light in the blackness. But most of the camp is dark. Inside the tents, the soldiers lie down. They pull their heavy woolen cloaks over themselves. They adjust their positions, finding space among the other bodies. They breathe slowly. The day's work is done. The ramparts stand solid around them. The wind passes overhead. The night begins. The completion of the perimeter fortifications marks a shift in the camp's rhythm. The urgent collective labour of digging and building gives way to smaller, more distributed tasks. One of the most critical is gathering firewood. Fire is essential, but not in the way it might seem. The soldiers do not rely on fire to heat their tents. The small enclosed papilio cannot safely accommodate an open flame. Instead, fire serves other functions. Cooking, boiling water for drinking, drying wet clothing, providing limited warmth to soldiers standing near the flames. These functions are important, but they are not automatic. Fire requires fuel, and fuel in the middle of winter on the northern frontier is not always abundant. The landscape varies. In forested regions, wood is plentiful. Deadfall litters the ground. Standing dead trees can be felled and sectioned. The soldiers can gather more than they need, building reserves for future camps. But in open plains, wood is scarce. The soldiers must search carefully, travelling farther from the camp to find suitable fuel. In some regions, the only available material is brushwood, small branches and twigs that burn quickly and provide minimal heat. In the worst cases, the soldiers must carry fuel with them, transporting it from the previous camp or requisitioning it from local settlements. The availability of fuel directly affects the camp's habitability. A camp with abundant firewood allows soldiers to cook hot meals, dry their clothing, and warm themselves periodically throughout the night. A camp with limited firewood means cold food, damp clothing, and no external source of warmth. The soldiers are aware of this dependency. When they halt for the night, one of the first questions is, where is the nearest wood? If the area is forested, the anxiety decreases. If the area is open, the concern grows. The task of gathering fuel is assigned to specific work details. These details leave the camp through the gates, moving out into the surrounding terrain. They carry axes, saws, and ropes. Their goal is to return with as much usable wood as possible before full darkness arrives. The work is physically demanding. Trees must be felled. Branches must be cut. Logs must be split. The wood must be carried back to the camp, sometimes over distances of several hundred meters. The soldiers work quickly, knowing that time is limited. The wood is inspected before it is collected. Dry wood is preferred. It ignites easily and burns cleanly. Wet wood is harder to light and produces excessive smoke. Green wood, freshly cut from living trees, is avoided entirely. It contains too much moisture and burns inefficiently. Dead trees are ideal. They have been drying for months or years. The moisture content is low, the wood is brittle, easy to break. The soldiers look for trees that have fallen naturally, killed by disease or age. These trees are abundant in mature forests. Once collected, the wood is brought back to the camp and stacked in designated areas. The stacks are placed near the gates, easily accessible but not obstructing movement. The wood is sorted by size. Large logs are set aside for long-burning fires. Smaller branches are kept for kindling. The fires themselves are lit after the wood has been gathered and the camp has settled. The soldiers dig small fire pits, shallow depressions in the ground lined with stones. The pits are positioned in open areas, away from tents and other flammable materials. The fires are started using simple tools. A soldier strikes flint against steel, creating sparks. The sparks fall onto a small pile of dry tinder, shredded bark, dry grass or cloth fibres. The tinder ignites, small twigs are added, the fire grows, larger branches are placed on top. Within minutes, a steady flame is burning. The fires serve as communal gathering points. Soldiers cluster around them, holding out their hands to the warmth. The heat is intense but localized. Standing directly beside the fire, a soldier can feel warmth on his face and hands, but stepping back even a metre, the heat dissipates. The cold air quickly absorbs the warmth. This limitation is important. Fire is not a solution to the cold, it is a temporary supplement. A soldier can warm his hands for a few minutes, but he cannot stand beside the fire all night. He must eventually return to his tent, and when he does, the warmth he gained from the fire will quickly fade. Cooking is the fire's primary function. The soldiers prepare their evening rations using the shared cooking pot carried by each contubernium. Grain is ground into coarse flour using a hand mill. The flour is mixed with water to create a thick porridge. The porridge is cooked over the fire, stirred occasionally to prevent burning. The meal is simple but caloric. The grain provides energy. The hot porridge provides temporary internal warmth. The soldiers eat quickly, standing near the fire, holding their bowls close. After eating, the soldiers use the fire to perform other tasks. Wet clothing is hung on improvised racks near the flames. Boots are placed close to the fire to dry. Metal tools are checked for rust and oiled. Small repairs are made to equipment. These tasks are mundane, but they are necessary. Wet clothing loses its insulating properties. Damp wool is less effective than dry wool. Rusty tools are less reliable. The soldiers maintain their equipment because their survival depends on it. As the night deepens, the fires begin to burn down. The soldiers add more wood periodically, but they do not build the fires up to their full intensity. Fuel must be conserved. The wood gathered tonight must last through the morning. If the soldiers burn all their fuel in the first few hours, they will have nothing left for breakfast. This is another aspect of Roman discipline. The impulse is to burn more wood, to create more warmth, to push back the cold as much as possible. But the discipline response is restraint. Use only what is necessary. Save the rest. The fires are never left unattended. Soldiers take turns watching them, ensuring that sparks do not escape and ignite nearby materials. Fire is a tool, but it is also a danger. In a camp full of leather tents, wooden stakes, and dry straw, an uncontrolled fire could be catastrophic. As the soldiers finish their tasks and prepare to sleep, the fires are allowed to burn down to embers. The flames diminish. The light fades. The camp grows darker. The soldiers return to their tents. They crawl through the low entrance, crouching to avoid the ridgepole. Inside, the air is cold but still. The wind does not penetrate the leather walls. The other members of the contubernium are already settling in, arranging their cloaks, adjusting their positions. The last soldier to enter ties the entrance flap shut. The tent is now sealed. The interior is dark. The only sound is breathing and the occasional rustle of wool. Outside, the fires continue to burn, small points of light scattered across the camp. The sentries take their positions on the rampart. The watch begins. The soldiers lie down. They pull their cloaks tight. They press close to one another. The heat begins to accumulate. The night continues. The contubernium is the smallest unit of the Roman army. 8 men. They march together. They fight together. They eat together. And on the winter frontier, they sleep together. The bond is not sentimental, it is structural. The contubernium shares a single mule, which carries the tent, the hand mill for grinding grain, and the cooking pot. The mule belongs to all 8 men equally. If the mule dies, all 8 men suffer. If one man fails to maintain his equipment, all 8 men are affected. This shared dependency creates a practical intimacy. The soldiers know each other completely. They know who snores, who wakes early, who complains, who stays silent. They know each other's habits, weaknesses, and strengths. In civilian life, such closeness might be uncomfortable, but on campaign it is necessary. The contubernium is not a family, but it functions like one. The men rely on each other for survival in ways that go beyond military discipline. The tent they share is their only private space, though privacy is a relative concept. The papilio offers shelter from the elements and a barrier from the rest of this camp, but inside there is no privacy. 8 men in 9 square meters. Every sound is heard, every movement is felt. The soldiers accept this without complaint. They have no choice. The alternative is sleeping outside, exposed to the full force of the cold. The tent, cramped as it is, represents security. The mule that carries the tent is a constant concern. The animal must be fed, watered, and rested. On long marches, the mule's welfare is monitored carefully. If the mule becomes lame or sick, the contubernium must carry the tent themselves, adding 43 kilograms to their already substantial load. Each soldier already carries approximately 25 to 30 kilograms of personal equipment: armor, shield, weapons, tools, rations, water. The addition of tent sections would push the total weight beyond what most men can carry comfortably over long distances. The mule, therefore, is not a luxury. It is essential infrastructure. The soldiers treat the animal with care, not out of affection, but out of self-interest. When the contubernium reaches its assigned plot in the camp, the soldiers unload the mule first. The tent is unpacked, the cooking pot is set aside, the hand mill is placed near the fire pit. The mule is then led to the designated animal lines, where it is tethered with the other mules and given whatever fodder is available. With the mule cared for, the soldiers turn their attention to raising the tent. The process is efficient. The leather panels are unfolded and spread on the ground. The wooden poles are assembled. The ridgepole is lifted into position, supported by 2 vertical posts at either end. The leather is pulled over the frame and secured with stakes driven into the ground at regular intervals. Guy ropes are attached and tensioned, pulling the tent walls taut. The entrance flap is positioned facing away from the prevailing wind, minimizing drafts. The entire process takes less than 15 minutes. The soldiers have done it so many times that they do not need to communicate. Each man knows his role. The movements are automatic. When the tent is standing, the soldiers step back and inspect it. Is the ridgeline straight? Are the walls tight? Are the stakes secure? Small adjustments are made. A rope is tightened. A stake is repositioned. The tent settles into its final form. From the outside, the tent looks unremarkable. It is low, dark, and heavy. The leather is patched and worn. The seams show the signs of repeated repair. It is not elegant, but it is functional. The soldiers do not judge the tent by aesthetic standards. They judge it by a single criterion: will it keep them alive through the night? If the answer is yes, the tent is adequate. The interior of the tent is dim even during the day. The thick leather blocks most of the light. At night, with no fires allowed inside, the interior is completely dark. The soldiers navigate by touch and memory. The floor space is divided informally. There is no formal assignment of sleeping positions, but over time each man gravitates toward a preferred spot. The veterans often claim the positions farthest from the entrance, where drafts are minimized. The newer recruits sleep closer to the flap. This hierarchy is subtle but real. It is not enforced by rule. It emerges naturally from experience and seniority. A veteran does not need to demand the best position. The recruits defer automatically. The arrangement also reflects practical considerations. The men sleeping near the entrance are responsible for opening and closing the flap if someone needs to leave during the night. It is a small duty, but it matters. The veterans, having earned their place through years of service, are spared this minor inconvenience. Inside the tent, the soldiers organize their equipment with care. Shields are stacked vertically along the walls. Armor is placed near the entrance, accessible in case of alarm. Weapons are kept within arm's reach. Packs are pushed to the edges, creating as much clear floor space as possible. The organisation is not merely orderly, it is strategic. In the event of an attack, the soldiers must be able to arm themselves quickly, even in total darkness. Every item has a designated place. Confusion in the dark could be fatal. The clear floor space in the centre of the tent is where the 8 men will sleep. The area is small. Lying down, the men will be shoulder to shoulder, with minimal space between them. There is no room to turn over without disturbing the person next to you. There is no room to stretch out fully. The soldiers do not complain about the confinement. They understand its purpose. The tight spacing is not an unfortunate byproduct of limited resources. It is a deliberate strategy. 8 bodies in close proximity generate heat. The warmth from one man transfers to the men beside him. The air in the confined space warms gradually. The temperature inside the tent rises above the temperature outside. This rise is modest, perhaps 3 or 4 degrees Celsius. But in freezing conditions, 3 degrees is the difference between discomfort and danger. The soldiers know this from experience. They have slept in poorly organised tents, where men spread out too far, and they remember the cold that resulted. The density is uncomfortable, but it works. The soldiers prioritise survival over comfort. As the evening progresses and the camp settles into its nightly routine, the members of the contubernium gather at their tent. They have eaten their rations. They have completed their assigned tasks. Now they prepare to sleep. The preparation is methodical. Wet outer garments are removed and hung near the entrance. Boots are loosened but not removed. Frozen boots in the morning are impossible to put on. Wool cloaks are shaken out and inspected for dampness. The soldiers check each other's condition. Is anyone showing signs of excessive cold? Shivering that will not stop? Numbness in the extremities? These are warning signs. A soldier who cannot generate enough body heat becomes a liability. He will not contribute warmth to the collective. Worse, he may need to be warmed by the others, draining their limited thermal resources. If a soldier is too cold, the others take action. They rub his hands and feet to restore circulation. They give him extra layers. They position him in the centre of the group, where he will receive warmth from both sides. The contubernium takes care of its own. This mutual care is not altruism. It is practicality. A soldier who freezes during the night cannot march in the morning. A soldier who cannot march slows the entire army. The health of each individual affects the efficiency of the whole. The Romans understand this. The military system is designed around collective strength. Individual suffering is tolerated, but individual failure is not. The contubernium enforces this standard quietly, without official oversight. As full darkness arrives, the soldiers enter the tent. They crawl through the low opening, crouching to clear the ridgepole. Inside, the air is cold but still. The wind does not penetrate the leather. The soldiers arrange themselves on the ground. They lie on their sides, facing the same direction, packed tightly together. The heavy woolen cloaks are pulled over them, covering all 8 men. Sometimes there are 2 cloaks, sometimes 3, rarely more. The cloaks serve as communal blankets. Beneath them, the ground has been prepared. Straw or brush provides a thin layer of insulation. It is not much, but it reduces the rate of heat loss through conduction. The soldiers lie still, conserving energy. The last man to enter ties the entrance flap shut. The tent is sealed. The interior is now completely dark. There is no light from the moon or stars, no light from the fires outside, just blackness. The soldiers breathe slowly. They listen to each other. The sound of breathing, the rustle of wool, the occasional shift of position. These sounds are familiar, reassuring. The contubernium is together. The tent is secure. The night has begun. The papilios are made from goatskin. Not a single hide, but many hides sewn together into squared patches. The number varies depending on the size of the tent, but reconstructions suggest approximately 75 to 77 individual skins are required. The choice of goatskin is deliberate. Goat hide is lighter than cattle hide, but retains high tensile strength. It is durable enough to withstand repeated use, flexible enough to be folded and packed, and thick enough to provide meaningful protection from wind and rain. The process of turning raw hides into a functional tent is labour-intensive. The skins must be cleaned, treated and sewn. The edges must be trimmed to create uniform patches. The patches must be stitched together with strong thread, often sinew or waxed cord, to form large panels. The seams are critical. A poorly sewn seam will leak. Water will seep through the stitching, soaking the interior of the tent. Wet conditions inside the tent make sleep difficult and increase the risk of illness. The soldiers who maintain the tent inspect the seams regularly, restitching weak points before they fail. Evidence from Vindolanda, a Roman fort near Hadrian's Wall, provides detailed information about tent construction and maintenance. Excavations at the site uncovered fragments of discarded tents, heavily worn and patched. The fragments show that tents were repaired repeatedly, with new patches sewn over damaged areas. A tent might remain in service for years, its surface covered with layers of repairs. This pattern of continuous maintenance reflects the value placed on the tent. Leather is expensive. Goatskins must be sourced, processed, and transported. Replacing an entire tent is costly. Repairing it is more practical. The soldiers perform these repairs themselves. Each contubernium is responsible for maintaining its own equipment. If a seam splits, the soldiers restitch it. If a panel tears, they sew on a patch. The work is done during rest periods, using simple tools, needles, thread, and sometimes a leather punch to create new holes for stitching. When the tent is not in use, it is folded carefully and packed onto the mule. The folding process minimizes creases and prevents unnecessary wear. The tent is heavy even when dry, approximately 43 kilograms. When wet, the leather absorbs water, adding another 8 kilograms or more. This additional weight is a significant burden. The mule must carry the wet tent along with the other equipment. On long marches in rainy conditions, the mule's load increases steadily. The soldiers monitor the animal's condition closely. If the mule shows signs of exhaustion, the tent is unpacked and allowed to dry whenever conditions permit. Drying a wet leather tent is difficult. Leather does not dry quickly, especially in cold, damp climates. The soldiers spread the tent out on the ground when the camp is established, allowing air to circulate. If the sun appears, they position the tent to maximize exposure. But in winter, sunny days are rare. Often the tent remains damp for days or weeks. The soldiers sleep under wet leather. The interior of the tent smells of mildew and animal hide. The dampness is unpleasant, but it is tolerable. The tent still provides wind protection. It still creates a barrier. Damp leather is better than no shelter. When the contubernium reaches its assigned plot and begins raising the tent, the first step is unfolding the panels. The leather is stiff from being packed. The soldiers pull it open, shaking out the folds. Small pieces of dirt and debris fall away. The panels are laid flat on the ground, aligned according to the tent's design. The tent has a simple shape. 2 rectangular panels slope upward from the ground and meet at a central ridgeline. The ends are closed with triangular pieces. The entrance is a flap that can be tied open or shut. The wooden poles are assembled next. The ridgepole runs the length of the tent, supported at either end by vertical posts. Additional poles may be used to support the sides, depending on the tent's design. The poles are plain, undecorated, cut from local timber when possible. The soldiers lift the ridgepole into position, holding it steady while others secure the vertical supports. The leather panels are then pulled over the frame. This requires coordination. One soldier cannot raise the tent alone. The leather is too heavy, the frame too unstable. 2 soldiers hold the poles, 2 others lift the leather. The remaining 4 position the edges and drive the stakes. The work is synchronized. When the ridgepole is stable, the leather is pulled taut and the stakes are driven into the ground. The stakes are driven at an angle, pointing away from the tent. This angle provides resistance. If the tent is pulled by wind, the stakes hold firm. If driven vertically, the stakes would pull out more easily. Guy ropes are attached to reinforced points on the tent's exterior. These ropes run from the tent to additional stakes placed several feet away. The ropes are tensioned, pulling the tent walls tight. Proper tension is essential. A loose tent flaps in the wind, creating noise and allowing drafts. A tight tent is stable and quiet. The soldiers adjust the tension carefully, checking each rope, ensuring the tent is balanced. If one side is tighter than the other, the tent will lean. A leaning tent sheds rain poorly and creates uneven interior space. Once the tent is raised and tensioned, the soldiers inspect it. They walk around the perimeter, checking the stakes, testing the guy ropes, looking for gaps or weak points. If the ground is soft, additional stakes may be added to prevent the tent from shifting during the night. The entrance flap is positioned last. It is tied to one side, allowing access while the tent is being prepared. Later, when the soldiers enter for the night, the flap will be tied shut from the inside. The completed tent is low. The ridgeline reaches approximately 2.2 meters at its highest point. The sides slope down to the ground. A tall soldier cannot stand upright inside except directly beneath the ridgeline. Movement inside the tent requires crouching or kneeling. This low profile serves a purpose. A low tent presents less surface area to the wind. It is more stable in storms. It is less likely to be torn from its stakes. The low ceiling also reduces interior volume, which aids in heat retention. From a distance, the tent is nearly invisible. The dark leather blends with the earth. In a camp of hundreds or thousands of tents, the individual papilio disappears into the mass. Only up close does its shape become distinct. The texture of the leather is rough. Goatskin retains the pattern of the animal's hair, even after processing. Running a hand over the surface, you can feel the grain. The patches are visible, slightly different in colour and thickness. The seams create raised lines where the stitching holds the panels together. The tent has no windows, no ventilation holes. The only opening is the entrance flap. This makes the interior dark and airless, but it also makes the tent warmer. Heat cannot escape through gaps, wind cannot enter. The soldiers understand this trade-off. Comfort is sacrificed for warmth. Fresh air is sacrificed for thermal efficiency. The tent is not designed for pleasant living, it is designed for survival. When the tent is fully raised and secured, the soldiers begin moving their equipment inside. Shields first, then armour, then packs. Each item is placed deliberately, positioned to maximise the usable floor space. The tent is now ready. The leather shell stands solid. The frame is stable. The interior is organised. The contubernium has created a small enclosed space in the middle of the vast open frontier. It is not much, 9 square metres of sheltered ground, but it is enough. The interior of the papilio is measured not in comfort but in function. 3 metres wide, 3 metres long, 2.2 metres high at the ridge. These dimensions define the limits of the soldier's private world. 9 square metres of floor space for 8 men. The arithmetic is simple. Each soldier occupies slightly more than 1 square metre. 1 metre by 1 metre. A space barely large enough to lie down without touching the tent walls. But the soldiers do not lie in isolation. They lie together, pressed close, overlapping. The 1 square metre per person is a theoretical maximum. In practice, the spacing is tighter. The height of the tent restricts movement. Standing upright is possible only directly beneath the ridgeline, and even then, a tall soldier's head nearly touches the leather. Away from the centre, the ceiling slopes down sharply. Within a metre of the walls, the clearance is less than 1.5 metres. This low ceiling forces the soldiers to crouch or crawl when moving inside the tent. There is no casual walking. Every movement is deliberate, careful. A soldier entering the tent ducks his head, bends at the waist, and moves in a half-crouch toward his assigned position. The restriction is constant. Even sitting requires awareness of the ceiling. A soldier who sits up too quickly risks striking his head on the ridgepole or the sloping leather. The bruises and bumps that result are minor, but they accumulate over time. The soldiers adapt to this confinement. They learn to move efficiently into the cramped space. They develop an instinctive awareness of the ceiling height, the position of the poles, the location of their equipment. Movement becomes automatic. New recruits struggle initially. They are not accustomed to such tight quarters. They bump into the poles. They knock over equipment. They disturb the other members of the contubernium. But over time, they learn. The tent becomes familiar. The movements become fluid. The volume of air inside the tent is limited. 3 metres by 3 metres by an average height of roughly 1.5 metres yields approximately 13 to 15 cubic metres of air. This is the total atmospheric space shared by 8 men. In a larger structure, this volume would be insufficient. The air would become stale quickly, carbon dioxide would accumulate, oxygen would deplete. The occupants would feel the effects: headache, dizziness, nausea. But the papilio is not sealed. The leather is porous. Air moves through the material, slowly but continuously. The entrance flap, even when tied shut, is not airtight. Small gaps allow air exchange. The tent breathes. This permeability prevents the buildup of dangerous gases, but also allows heat to escape. The tent cannot be made perfectly airtight without creating a lethal environment. The balance between ventilation and insulation is delicate. The soldiers do not understand the chemistry of respiration, but they understand the practical result. A tent that is too tightly sealed feels oppressive. The air becomes heavy, breathing is uncomfortable. A tent with too many gaps is cold, heat escapes, the interior temperature drops. The standard papilio achieves a rough balance, enough airflow to prevent suffocation, enough insulation to retain some warmth. The design is not perfect, but it is functional. The confined space also affects sound. Noises inside the tent are amplified. A whisper is clearly audible. The rustle of clothing sounds loud. The breathing of 8 men creates a constant rhythmic background noise. This acoustic environment is initially unsettling for new recruits. They are not used to hearing every sound their companions make. Every cough, every shift of position, every murmured word is unavoidable. Privacy, in the auditory sense, does not exist. Veterans grow accustomed to this. They learn to filter the sounds, to distinguish between normal nighttime noises and sounds that indicate a problem. A change in breathing pattern, a groan of pain, the sound of someone moving toward the entrance, possibly ill or needing to relieve themselves. The veterans also learn to sleep through the noise. The constant low-level sound becomes background. It is always present. So it ceases to be disruptive. The mind adapts. The smallness of the tent creates an unavoidable intimacy. 8 men cannot occupy 9 square meters without constant physical proximity. During the day, when the soldiers are moving in and out, preparing equipment, or resting briefly, the contact is intermittent. But at night, when all 8 men lie down to sleep, the contact is continuous. Shoulder touches shoulder, hip presses against hip, legs overlap, feet rest against the next man's calves. There is no gap between bodies. The soldiers form a single mass, compressed together beneath the heavy woolen cloaks. This physical intimacy is neither affectionate nor hostile. It is functional. The soldiers tolerate it because they must. The warmth generated by this closeness is essential for survival. Discomfort is accepted as the price of not freezing. The soldiers also develop habits to manage the confinement. They agree, often without explicit discussion, on how to arrange themselves. Who sleeps on the left? Who sleeps on the right? Who is in the centre? The arrangement is usually consistent from night to night, creating a predictable routine. Predictability reduces friction. If every night the sleeping positions were different, the soldiers would waste time and energy negotiating. By falling into a pattern, they eliminate that source of conflict. The dimensions of the tent also dictate how equipment is stored. There is no room for disorder. Everything must be placed carefully, tucked against the walls or stacked at the ends. A carelessly placed shield can obstruct movement. A pack left in the wrong position can reduce the available sleeping space. The soldiers are meticulous about organisation, not out of preference but out of necessity. In the confined space, disorder is intolerable. The tent's low profile also affects its relationship to the outside environment. Snow accumulates on the sloping sides. Rain runs down the leather and pools at the base. The tent sags slightly under the weight of accumulated precipitation. The soldiers must periodically shake the tent from the inside, dislodging snow or water before the weight becomes too great. If snow accumulates too heavily, the tent can collapse. A collapsed tent in the middle of the night is dangerous. The soldiers would be exposed to the cold, disoriented in the darkness. This has happened. Tents have collapsed under snow loads. The soldiers inside wake suddenly, trapped beneath heavy wet leather. They must fight their way out, untangle themselves and re-raise the tent in freezing conditions. It is exhausting and demoralizing. To prevent this, the soldiers check the tent periodically during heavy snowfall. Someone wakes, reaches up and pushes against the leather, dislodging the accumulated snow. The task rotates among the contubernium. No one wants to be the person who lets the tent collapse. The confined dimensions also mean that heat, once generated, stays relatively concentrated. The soldiers' bodies produce thermal energy continuously. In an open space, this heat would disperse into the surrounding air. But in the small enclosed tent, the heat has nowhere to go. It accumulates. The temperature inside the tent rises slowly, not dramatically. The interior never becomes warm, but it becomes warmer than the outside, warm enough to make sleep possible. The soldiers feel this change. When they first enter the tent, the air is cold, their breath is visible. But after an hour of lying together, the air temperature has risen. The breath is less visible, the cold is less penetrating. The dimensions of confinement, uncomfortable as they are, enable survival. The tent is small because it must be small. A larger tent would require more material, more weight, more labour to raise, and a larger tent would be colder. The soldiers endure the cramped space because the alternative is worse. Comfort is a luxury, survival is the goal. The papilio provides just enough space to survive, and just enough space is enough. The Roman soldier's defence against the cold is built in layers. The outer layer is the tent. The inner layers are wool. Wool is the dominant material in the soldier's clothing system. It is abundant in the provinces where the legions campaign. It is relatively inexpensive. It is durable. And most importantly, it retains warmth even when wet. This last property is critical. On the northern frontier, everything becomes wet. Rain falls frequently. Snow melts and soaks into clothing. The soldiers wade through rivers and marshes. Sweat accumulates during marches. Wet conditions are constant. Other materials lose their insulating properties when wet. Linen, for example, becomes cold and clammy. Leather stiffens, but wool continues to insulate. Wet wool is less effective than dry wool, but it still traps air and slows heat loss. This resilience makes wool the foundation of the soldier's thermal strategy. The basic garment is the tunic. The tunica is a simple knee-length woolen shirt. It is worn directly over a linen undergarment called the sublegaculum. The linen layer serves a practical purpose. It absorbs sweat and can be washed more easily than wool. Clean linen against the skin reduces chafing and irritation. The tunic itself is made from coarse, undyed wool in many cases. The fabric is heavy and dense. It is not soft. The fibres are rough against the skin, but softness is not a priority. The tunic is designed to insulate, not to comfort. A single tunic is not sufficient in winter. The soldiers layer multiple tunics. 2 tunics are common. 3 tunics are not unusual. In extreme cold, soldiers have been known to wear 4 or more. Historical accounts mention that Emperor Augustus, known for his sensitivity to cold, habitually wore 4 tunics simultaneously. This practice was recorded as noteworthy but not absurd. It was understood that layering was an effective response to cold. The soldiers adopt the same strategy. Each additional tunic adds another layer of insulation. Air is trapped between the layers. This trapped air resists heat transfer, keeping the soldier's core temperature stable. The tunics are not identical. The innermost tunic is often the oldest, most worn. The outer tunics are newer, in better condition. This layering reflects both practicality and economy. The inner tunic closest to the skin wears out faster from washing and sweat. Placing the worn tunic inside and the newer tunic outside extends the useful life of both garments. In addition to the standard issue tunics, soldiers often purchase locally made tunics with long sleeves. The standard military tunic has short sleeves or no sleeves. This is adequate in the Mediterranean but insufficient in northern winters. Local markets near military camps produce tunics designed for cold weather. These tunics have long sleeves that extend to the wrists. They are made from locally sourced wool, often thicker and heavier than the regulation material. The soldiers buy these tunics with their own money and wear them underneath their official uniform. This practice is tolerated by the military authorities. The army recognises that regional adaptation is necessary. Soldiers in Germania need different clothing than soldiers in Syria. The regulations are flexible enough to permit local modifications. Evidence from the Vindelander tablets provides direct confirmation of this practice. The tablets are thin wooden sheets used for correspondence. They were discovered at the Roman fort of Vindelander, near Hadrian's Wall. Many of the tablets contain personal letters between soldiers and their families. One tablet includes a request for specific items to be sent from home. The soldier asks for socks, underpants, and sandals. The specific mention of socks is significant. Socks, called udones, were not standard military issue. They were personal items, obtained through private means. The request for socks indicates that the soldier's feet were cold. The standard military footwear, the caligae, were open sandals with hobnailed soles. They provided excellent traction and durability but minimal insulation. In cold weather, the feet were exposed. Socks made from wool provided a partial solution. The wool covered the foot and lower leg, adding a layer of insulation. The socks were worn underneath the sandals, an awkward but effective compromise. In addition to socks, the soldiers used leg bindings called fascia. These were long strips of wool or linen wrapped around the lower legs. The wrapping technique varied, but the principle was consistent. Multiple layers of fabric provided insulation and support. The fascia served a dual purpose. They kept the legs warm, and they protected the skin from chafing caused by the metal greaves or armour. The bindings were wrapped tightly, compressing the fabric and creating a firm supportive layer. The neck is another critical area for heat retention. The human body loses a significant amount of heat through the neck and head. A soldier wearing multiple tunics but leaving his neck exposed will still lose core temperature rapidly. The Romans addressed this with a garment called the focale. The focale was a scarf or neckcloth wrapped around the throat and tucked into the tunic. It sealed the gap between the tunic and the helmet or bare head, preventing heat from escaping. The focale was originally developed to prevent the armour from chafing the neck. The metal edge of the lorica segmentata or chainmail could rub against the skin during long marches, causing painful sores. The focale provided a protective barrier, but the focale also had a thermal function. By covering the neck, it reduced heat loss. The soldiers recognised this benefit and wore the focale even when not wearing armour. In cold weather, the focale was essential. Over the tunics and undergarments, the soldiers wore heavy cloaks. Two types of cloaks were common, the sagum and the paenula. The sagum was a rectangular, woolen cloak fastened at the shoulder with a brooch. It was large and heavy, made from thick, coarse wool. The weight of the sagum was substantial. When dry, it could weigh several kilograms. When wet, the weight doubled. This weight was not a disadvantage. The heavy wool provided excellent insulation. The dense fibres trapped air effectively. The sagum could be wrapped around the entire body, covering the torso, arms and legs. At night, the sagum functioned as a blanket. The paenula was a different design. It was a hooded cloak shaped like a poncho. The paenula was pulled over the head and hung down to the knees or lower. The hood, called a cucullus, provided protection for the head and neck. The paenula was particularly useful in rain. The hood kept the head dry. The cloak's design allowed water to run off without soaking the underlying layers. The paenula was often made from felted wool, which had even better water resistance than woven wool. Felting is a process that compresses wool fibres into a dense, matted fabric. Felted wool is less flexible than woven wool, but it is more windproof and water-resistant. A well-made felted cloak, such as the gausapa, could shed light rain almost completely. The water resistance of wool comes from lanolin. Lanolin is a natural fat present in sheep's wool. It coats the fibres, repelling water. When wool is washed thoroughly, the lanolin is removed. The wool becomes cleaner, but loses its waterproofing. The Romans understood this trade-off. Wool intended for dyeing was washed with harsh substances, including stale urine, which contains ammonia. The ammonia removed oils and dirt, allowing the dye to penetrate the fibres, but it also removed the lanolin. For military cloaks, especially those intended for cold, wet climates, the wool was often left unwashed or minimally washed. The lanolin remained in the fibres. The cloak retained its natural water resistance. The trade-off was that the cloak smelled strongly of sheep and felt greasy to the touch. The soldiers accepted this. A cloak that smelled bad but kept them dry was preferable to a clean cloak that soaked through. Practicality always outweighed comfort. In addition to the standard military garments, the soldiers adopted local clothing when necessary. The most significant adoption was trousers. Trousers, called bracae, were not part of traditional Roman culture. They were associated with barbarian peoples, particularly the Gauls and Germans. Romans viewed trousers as foreign, uncivilized, even effeminate. But on the northern frontier, this cultural prejudice was set aside. The soldiers needed leg protection. Short tunics left the legs exposed to cold and wind. Wrapping the legs in fascia helped, but it was not enough. Trousers provided full coverage. They were made from thick wool or leather. They extended from the waist to the ankles, enclosing the entire leg. Some trousers were full length, others ended at the knee, resembling breeches. The adoption of trousers was gradual. Initially, wearing trousers was discouraged. It was seen as abandoning Roman identity, But as the Legion spent more time in cold climates, the resistance faded. Soldiers began wearing braca routinely. Officers tolerated it. Eventually, trousers became standard issue in certain provinces. This shift from cultural resistance to practical acceptance illustrates the flexibility of the Roman military system. Doctrine was important, but survival was more important. When the two came into conflict, survival won. The layers of wool, tunics, socks, leg bindings, neckcloths, cloaks, and eventually trousers, formed a comprehensive insulating system. Each layer contributed to the overall thermal efficiency. Heat generated by the body was trapped close to the skin, cold air was kept at bay. The system was not perfect. The soldiers were still cold, but they were cold in a way that was survivable. The wool kept them alive through the night, and in the morning, when they rose and shook the snow from their cloaks, they were ready to march again. The Vindolanda tablets offer a rare, intimate glimpse into the daily concerns of Roman soldiers stationed on the northern frontier. These wooden sheets, thin and fragile, were used for correspondence. Letters were written in ink on one side. The tablets were then folded and tied, creating a sealed message that could be carried by courier. Hundreds of these tablets have been recovered from the waterlogged soil at Vindolanda. The anaerobic conditions preserved the wood and ink, allowing modern scholars to read messages written nearly 2,000 years ago. The content of the tablets is varied. Some are official military documents, others are personal letters. The personal letters reveal the concerns, requests, and anxieties of soldiers far from home. One tablet, catalogued as Tablet 346, contains a short list of items requested by a soldier. The list includes socks, underpants, and sandals. The brevity of the request makes it more poignant. These are not luxury items, they are basic necessities. The request for socks is particularly telling. Socks, udones, were not standard military issue. They were personal items, obtained through private means. The fact that a soldier had to write home asking for socks indicates that the available supplies were insufficient. The soldiers' feet were cold. The standard military sandals, the caligae, did not provide adequate insulation. The hobnails on the soles conducted cold from the frozen ground directly to the feet. Frostbite was a constant risk. Wool socks provided a partial solution. They could be worn inside the sandals, creating a layer of insulation between the foot and the cold leather. The socks absorbed moisture, keeping the feet drier. Dry feet were warmer feet, but socks were not durable. Wool, when worn directly against the foot and subjected to the friction of walking, wore out quickly. Holes appeared, heels thinned, the sock lost its insulating properties. New socks were needed constantly. The soldier's request suggests that replacement socks could not be obtained locally. Perhaps the supply was unreliable. Perhaps the quality of locally made socks was poor. Perhaps the cost was too high. Whatever the reason, the soldier turned to his family, asking them to send socks from home. The request for underpants or subligaria reflects similar concerns. Undergarments were worn beneath the tunic to absorb sweat and provide a layer of comfort. They were washed frequently, which meant they wore out quickly. Replacing worn undergarments was a constant need. The soldier could not simply go without. Chafing from the rough wool tunic would make marching painful. Hygiene would suffer. Skin infections would develop. Again, the soldier writes home. The implicit message is clear. The items he needs are not available through military supply channels. He must rely on family networks to provide what the army cannot or will not provide. The request for sandals is slightly different. Sandals were standard issue, but standard issue did not mean adequate. The caligae provided to soldiers were designed for durability, not comfort. The heavy leather and iron hobnails could withstand long marches on hard roads, but in wet, cold conditions they were far from ideal. The soldier may have been asking for a different type of sandal, perhaps something locally made with better insulation. Or perhaps his issued sandals were worn out and the replacement process was too slow. Either way, the request indicates a gap between official supply and practical need. Another tablet, Tablet 291, contains a different kind of request. A soldier stationed at Vindolanda writes to a friend or family member, asking them to send him warm clothing. The specific items are not listed, but the tone of the letter is urgent. He writes that he is cold and needs help. The emotional content of this letter is significant. The soldier is not merely requesting items, He is expressing vulnerability. He is admitting that the conditions are difficult. He is asking for assistance in a way that suggests the official supply system is not meeting his needs. These letters challenge the image of the Roman soldier as a uniformly equipped, well-supplied professional. The reality was more complicated. Standard issue equipment was often insufficient for local conditions. Soldiers had to supplement their gear through personal means. Family connections were essential. The tablets also reveal the informal networks that sustained the army. Soldiers wrote to family members, friends, and patrons requesting specific items. These items were purchased or made at home and then shipped to the frontier. The shipment might take weeks or months, but eventually the package arrived. The soldier who received socks from home was better prepared for the cold than the soldier who did not. This created inequality within the ranks. Soldiers with supportive families had better gear. Soldiers without such support suffered more. The military authorities were aware of this disparity but did little to address it. The assumption was that soldiers would take care of themselves. The army provided basic equipment. Anything beyond that was the soldier's responsibility. This system worked, to a degree. Most soldiers did manage to acquire the additional items they needed, but it placed a burden on families. A soldier's family was expected to support him financially and materially, even while he was on campaign far from home. The requests in the Vindolanda tablets also highlight the importance of specific items. Socks appear in multiple letters, leg bindings are mentioned, warm tunics are requested. These items, small and seemingly minor, were essential for survival. A soldier without socks faced frostbite. A soldier without leg bindings faced chafing and exposure. A soldier without a warm tunic faced hypothermia. The difference between having these items and not having them was the difference between maintaining operational effectiveness and becoming a casualty. The cold was not a dramatic threat. It did not kill quickly, but it eroded strength gradually. A soldier who was chronically cold became slower, weaker, more prone to illness. Over weeks and months, the cold reduced the army's fighting capacity. The Roman military understood this. They recognized that keeping soldiers warm was a strategic necessity, but they also relied on soldiers to manage their own welfare. The army provided a baseline. Soldiers were expected to exceed that baseline through personal initiative. The Vindolanda tablets show this system in action. Soldiers wrote home, families responded, items were sent, soldiers stayed warmer. The army remained operational, but the system had limits. Not every soldier had a family capable of sending packages. Not every package arrived. Not every item was available. Some soldiers suffered more than others. The letters also reveal the isolation of the frontier. Vindolanda was located in northern Britannia, far from the urban centres of the empire. The landscape was harsh, the weather was relentless. The soldiers stationed there were separated from their homes by weeks of travel. This separation created psychological strain. The letters from Vindolanda often expressed loneliness and longing. Soldiers missed their families. They asked for news from home. They requested small personal items that reminded them of their former lives. The request for socks, in this context, is not merely practical, it is also emotional. The socks are a tangible connection to home. They are made by familiar hands sent with care. Wearing them, the soldier feels less alone. The tablets also show the bureaucratic challenges of military supply. Some letters reference delayed shipments. Others mention items that were promised but never arrived. The supply chain was long and fragile. Items could be lost, stolen, or diverted. Soldiers learned to work within this system. They sent multiple requests, hoping that at least one would succeed. They cultivated relationships with merchants and traders who could provide goods locally. They traded with other soldiers, exchanging items they had for items they needed. This informal economy supplemented the official supply system. It allowed soldiers to acquire what they needed, even when official channels failed. But it also created dependencies and inequalities that the military authorities could not fully control. The Vindolanda tablets, with their simple requests for socks and underpants, reveal the reality of life on the cold frontier. Survival depended not only on discipline and training, but also on wool, leather, and the support of distant families. The soldiers endured, they wrote their letters, they waited for replies. and when the packages finally arrived, they unpacked the socks and pulled them on, grateful for the small measure of warmth they provided. As darkness settles over the camp and the soldiers prepare to sleep, the heavy woolen cloak undergoes a transformation. What served as outerwear during the day becomes bedding at night. The sagum is the primary cloak used by the common legionary. It is a large rectangular piece of wool, typically measuring about 2 meters by 1.5 meters. The fabric is thick, woven from coarse fibers. The colour varies. Undyed wool is common, giving the cloak a natural grey or brown tone. Some saga are dyed red or dark blue, though the dye fades with use and exposure. During the day, the sagum is worn draped over the shoulders and fastened with a fibula, a metal brooch at the right shoulder. This leaves the right arm free for weapon use while covering the rest of the body. The cloak hangs down to mid-thigh or knee, providing coverage without restricting movement. The weight of the sagum is considerable. A dry cloak weighs several kilograms. The thick wool makes it cumbersome to wear in warm weather, but in winter the weight becomes an asset. Heavy wool means dense insulation. When the soldiers enter their tent at night, they remove the fibula and unfasten the cloak. The sagum is no longer needed as outerwear. Inside the tent, sheltered from wind and rain, the cloak serves a different purpose. The soldiers spread their saga across the sleeping area. Sometimes the cloaks are laid flat, covering the ground. Sometimes they are draped over the men as they lie down. The method varies depending on how many cloaks are available and how cold the night is. In an ideal situation, each contubernium would have 8 saga, 1 per man. In practice, the number is often lower. Cloaks wear out. They are lost. They are damaged beyond repair. Replacement takes time. A contubernium might have only 5 or 6 serviceable cloaks at any given time. This shortage affects the sleeping arrangements. With fewer cloaks, the soldiers must share. 2 men might share 1 cloak, lying close together, to maximise coverage. Or the available cloaks might be pooled, with some placed beneath the men and others placed on top. Historical accounts suggest that in times of extreme scarcity, the soldiers used 1 cloak as ground insulation and 1 as a covering, with multiple men sharing both. This arrangement required tight packing. The men lay shoulder to shoulder, the bottom cloak spread beneath them, the top cloak pulled over all of them. The shared cloak created a collective thermal envelope. The wool trapped the heat generated by the men's bodies. The airspace between the cloak and the skin warmed gradually. The temperature beneath the cloak became noticeably higher than the ambient air temperature in the tent. This system depended on continuous contact. If a gap opened between the men, cold air would enter the space beneath the cloak. The heat would escape. The thermal envelope would collapse. The soldiers learned to lie still, maintaining contact, preserving the warmth they had collectively generated. The texture of the sagum was rough against bare skin. The wool was not processed for softness. The fibres retained their natural coarseness. Soldiers wore their tunics while sleeping, creating a barrier between skin and cloak. The tunic absorbed sweat and prevented the worst of the chafing. The cloak also absorbed moisture. Wool has a natural capacity to absorb water vapour without feeling wet to the touch. A woolen cloak can absorb up to 30% of its weight in moisture while still providing insulation. This property is critical in the damp conditions of the northern frontier. During the night, the soldiers exhale moisture with every breath. 8 men breathing in a confined space produce a significant amount of water vapour. This vapour condenses on the coldest surfaces, the leather walls, the ground, to some extent the woolen cloaks. A cloak that could not absorb this moisture would become saturated quickly, losing its insulating properties. But wool absorbs the vapour, keeping the surface relatively dry. The soldiers sleep under damp wool, but damp wool is far better than wet linen or soaked leather. In the morning, the cloaks are often noticeably heavier. The absorbed moisture adds weight. The soldiers shake out the cloaks when they rise, trying to release some of the accumulated dampness. Water droplets fall. Sometimes, if the night was particularly cold, small ice crystals shake loose. The pennula, the hooded cloak, serves a slightly different function. Its shape makes it less practical as a blanket. The pennula is worn rather than spread, but in extreme cold, soldiers sometimes sleep in their pennulae, pulling the hood over their heads for additional warmth. The hood is valuable. The head loses heat rapidly. A bare head in freezing temperatures can drain body warmth faster than any other exposed area. The hood of the pennular covers the head, trapping heat that would otherwise escape into the cold air. Some soldiers sleep with their heads covered by the cloak, breathing the warmer air trapped beneath the wool. This creates a small enclosed breathing space. The exhaled breath warms the air in this space, which is then inhaled again. The cycle creates a slightly warmer microclimate around the face and head. The disadvantage is that the enclosed space can feel suffocating. The air becomes stale. The wool smells strongly. Some soldiers tolerate this. Others prefer to leave their faces exposed, accepting the cold in exchange for fresh air. The cloaks also serve as padding. The ground beneath the tent is hard. Even with straw or brush spread as insulation, the surface is unforgiving. The soldiers lie on the frozen earth, compacted by the weight of boots and equipment. Without padding, pressure points develop. Hips, shoulders, and elbows press into the hard ground, causing pain and restricting blood flow. A cloak spread beneath the body provides minimal cushioning. It does not eliminate the hardness, but it distributes the pressure slightly more evenly. The wool compresses under the weight, but it does not compress completely. Some cushioning remains. This is more comfortable than lying directly on the ground, but comfort is relative. The soldiers are not seeking softness. They are seeking survivability. The cloak beneath them prevents the rapid conductive heat loss that would occur from direct contact with frozen earth. The cushioning is secondary. The durability of the sagum is tested nightly. The cloak is subjected to constant stress. It is laid on rough ground, it is slept on by multiple men, it is pulled and tugged, it absorbs sweat, breath vapour, and sometimes blood from minor wounds. Over time, the wool thins, the fibres break down, holes appear, the edges fray. The soldiers repair the cloaks as best they can, sewing patches over damaged areas, re-hemming frayed edges. But eventually the cloak becomes too worn to function effectively. A worn cloak provides less insulation. The thinned wool traps less air. The holes allow heat to escape. A soldier with a badly worn cloak is noticeably colder than a soldier with a newer cloak. This creates inequality within the contubernium. The military supply system is supposed to replace worn cloaks, but replacement is not always timely. A soldier might submit a request for a new cloak and wait weeks or months for it to arrive. In the meantime, he makes do with what he has. The cloak's transformation from garment to bedding is a daily ritual. As the soldiers settle into the tent, they remove their cloaks and arrange them. The process is familiar, automatic. Each man knows where his cloak will go, how it will be positioned, who will share it. There is little conversation during this process. The soldiers are tired. They have been awake since before dawn and they have marched for hours. They have dug trenches and raised tents. They have cooked and eaten and performed their duties. Now they want to sleep. The cloaks are spread. The men lie down. The wool settles over them, heavy and rough. The heat begins to build. The night continues. The sagum, which began as a piece of military equipment designed for protection and identification, becomes in these hours something more essential. It becomes the barrier between the soldier and the cold. It becomes the shared warmth that allows 8 men to survive until morning. When dawn comes, the cloaks will be shaken out, refastened, and worn again. The cycle will repeat. But for now, in the darkness of the tent, the cloak serves its most important function. It keeps the soldiers alive. The adoption of trousers by Roman soldiers represents a quiet but significant shift in military culture. For centuries, Roman identity had been tied to specific forms of dress. The toga for citizens, the tunic for daily wear, bare legs as a mark of civilization. Trousers were associated with barbarians. The Gauls wore them, the Germans wore them, the peoples of the northern steppes wore them. To Roman eyes, trousers were foreign, uncivilized, even ridiculous. They were a symbol of everything Rome was not. This cultural prejudice was strong. It was reinforced by law, custom, and social expectation. A Roman man did not wear trousers. To do so was to abandon Roman identity to become something other than Roman. But on the northern frontier, this prejudice encountered a problem. The climate did not care about cultural identity. The cold was indifferent to tradition, and bare legs, exposed to freezing temperatures, wind and wet conditions, could not remain functional. The soldiers suffered. Frostbite affected the lower legs. Skin cracked and bled. Circulation was restricted. Men who could have marched became unable to walk. The casualty rate from cold-related injuries increased. The military authorities faced a choice: maintain cultural purity and accept reduced operational effectiveness, or permit the adoption of foreign clothing and preserve the army's fighting capacity. Pragmatism 1. The shift was gradual. It did not happen through official decree. Instead, individual soldiers began wearing trousers quietly, acquiring them from local sources. Officers initially disapproved, but they did not enforce the prohibition strictly. As long as the soldiers remained effective, the violation of dress codes was tolerated. Over time, tolerance became acceptance. Trousers appeared more frequently. New recruits arriving in northern provinces saw veterans wearing them and adopted the practice. The cultural stigma faded, replaced by a practical recognition that trousers were necessary equipment in cold climates. By the late 1st century and into the 2nd century, trousers had become standard issue in certain provinces. The army formally acknowledged what soldiers had been doing informally for years. The barbarian garment had become Roman military gear. The trousers worn by Roman soldiers were called bracae. The term itself was borrowed from the Gaulish language, another indication of the garment's foreign origin. The design varied, but the basic form was consistent. A covering for each leg joined at the waist, extending down to the ankle or knee. Full-length bracae covered the entire leg. They were tied or fastened at the waist and sometimes at the ankle. The fabric was typically wool, though leather bracae also existed. Wool was preferred for daily wear because it was more flexible and easier to wash. Knee-length bracae, resembling breeches, were also common. These provided coverage for the thighs while leaving the lower legs to be protected by fascia, the wrapped leg bindings. This combination offered flexibility. The soldier could adjust the amount of coverage based on conditions. The construction of bracae was simple. 2 rectangular or slightly tapered pieces of fabric were sewn together along the inner leg seams. A waistband was added, sometimes with a drawstring for adjustment. There were no pockets, no unnecessary features. The trousers were purely functional. The fit was loose. Tight trousers would restrict movement, which was unacceptable for soldiers who needed to march long distances and move quickly in combat. The loose fit also allowed air circulation, which helped with moisture management. Sweat could evaporate rather than being trapped against the skin. The wool used for bracae was often thicker and coarser than the wool used for tunics. Leg coverings endured more abrasion. The fabric had to withstand friction from walking, contact with brush and undergrowth, and the general wear of daily use. Thick wool lasted longer. Some bracae were lined with linen or lighter wool for additional comfort. The lining reduced chafing and absorbed sweat. Lined trousers were more expensive and less common, but they were valued by soldiers who could afford them. Leather bracae provided superior wind resistance and durability. They were particularly useful in extremely cold, dry conditions where wind chill was the primary threat. But leather was less breathable than wool. In damp conditions, leather trousers could become uncomfortable, trapping moisture against the skin. The decision between wool and leather often depended on the specific environment. Soldiers stationed in the wet, cold climate of Britannia preferred wool. Soldiers on the drier, windswept plains of Germania sometimes chose leather. The adoption of trousers also affected the soldiers' other equipment. The traditional caligae, the open military sandals, were designed to be worn with bare legs. When trousers were added, the relationship between footwear and legwear changed. Some soldiers continued wearing caligae over their trousers, tucking the trouser legs into the sandal straps. This was awkward but functional. Others switched to enclosed boots, which accommodated trousers more naturally. Boots provided better insulation for the feet and eliminated the need for complex tucking and wrapping. The shift from sandals to boots was another pragmatic adaptation. Like trousers, boots were initially seen as foreign, but they worked better in cold, wet conditions. The army gradually accepted them. The combination of wool trousers and enclosed boots created a thermal system for the lower body that was far more effective than bare legs and sandals. The legs were covered, the feet were insulated, heat loss through the extremities was reduced. This improved the soldier's ability to function in cold weather. Men who might have suffered frostbite instead remained healthy. The operational capacity of the army increased. The cost was a slight adjustment to cultural norms. The soldiers themselves did not view the adoption of trousers as a cultural surrender. They saw it as a necessary adaptation. The purpose of military equipment was to enable soldiers to fight effectively. If trousers enabled that, then trousers were appropriate military equipment. This pragmatic attitude extended to other elements of frontier life. Soldiers adopted local foods when they were more nutritious than standard rations. They learned local languages when communication with civilians was necessary. They incorporated local building techniques when constructing winter quarters. The Roman military was not rigid, it was adaptive. The core elements, discipline, organisation, training, remained constant, but the details were flexible. Equipment, tactics, and customs were adjusted to fit local conditions. The adoption of trousers is one example of this flexibility. It shows that Roman identity was not defined by clothing but by discipline and purpose. A soldier wearing brachiae was still a Roman soldier, as long as he fought with Roman discipline and served Roman objectives. The cultural shift also had broader implications. Soldiers who served on the northern frontier and then returned to other provinces brought their habits with them. Trousers began appearing in regions where they had previously been unknown. The practice spread through the army, carried by veterans who had experienced its benefits. By the 3rd and 4th centuries, trousers were widely accepted throughout the Roman military. The stigma had disappeared. The foreign had become familiar. What had once been barbarian was now simply practical. This transformation did not happen through official propaganda or cultural campaigns. It happened through the accumulated experience of thousands of soldiers who discovered that trousers kept them warmer, healthier, and more effective. The evidence of experience overrode the weight of tradition. The soldiers on the winter frontier, lying in their tents at night, wore their brachiae to sleep. The wool trousers provided a braziers, an additional layer of insulation, covering the legs completely, combined with the tunics, cloaks, and shared body heat. The trousers contributed to the thermal system that made survival possible. In the morning, when the soldiers rose and prepared to march, the trousers were already in place. There was no need to remove them. They were worn continuously, day and night, until they needed to be washed or repaired. This continuity was another advantage. Clothing that could be worn both day and night reduced the amount of gear the soldiers needed to carry. Simplicity meant efficiency. The adoption of trousers was complete. The cultural barrier had been crossed. The soldiers had accepted that survival required adaptation, and in accepting that, they had preserved the Roman army's ability to campaign in the coldest, harshest regions of the empire. The frontier shaped the army. The army, in turn, carried those changes back into the heart of the empire. Trousers were one small part of that process, but they were a visible part, a daily reminder that Rome's strength lay not in rigid adherence to tradition, but in the willingness to learn, adapt, and endure. Before the soldiers lie down to sleep, they must address the ground beneath them. Frozen earth is a relentless enemy. It draws heat from the body through conduction, draining warmth faster than it can be regenerated. The soldiers understand this danger, not through scientific knowledge but through experience. They have slept on unprepared ground before. They remember waking cold, stiff, unable to feel their limbs. They remember the exhaustion that comes from a night spent fighting the cold instead of resting. The solution is simple in principle but requires effort. A barrier must be placed between the body and the frozen earth, something that resists heat transfer, something that provides insulation. The ideal material is straw. It is light, abundant in agricultural regions, and highly effective as insulation. Straw is hollow. Each stalk contains air spaces. When straw is piled in a thick layer, these air spaces create a network of insulation. Heat cannot easily pass through the trapped air. The body's warmth is retained. But straw is not always available. The army is often campaigning in regions far from farms and fields. The landscape is wild, uncultivated. There are no crops to harvest, no straw to gather. In these situations, the soldiers improvise. They use whatever materials the environment provides. Dried grass, if it can be found. Leaves, collected from the forest floor. Pine boughs, cut from nearby trees. Pine boughs are particularly useful. The needles are dense and springy. When laid in overlapping layers, they create a resilient mat that compresses under weight but does not flatten completely. The mat provides both cushioning and insulation. The process of gathering these materials begins as soon as the camp perimeter is secure. While some soldiers are gathering firewood, others are collecting bedding materials. They move through the surrounding terrain looking for suitable vegetation. Dried grass is preferred over green grass. Dry material insulates better. It is also lighter and easier to transport. Green grass contains moisture, which conducts heat and adds weight. The soldiers pull up handfuls of grass, shaking, off the dirt. They bundle it loosely and carry it back to the tent. Multiple trips are often necessary. A single armload of grass is not enough to cover the tent floor adequately. Several armloads are needed to build a layer thick enough to provide meaningful insulation. Pine boughs require cutting. The soldiers use small hand axes or knives to sever branches from low-hanging limbs. They select branches that are thick with needles, but not so large that they are difficult to carry. The branches are trimmed to manageable lengths and stacked. When enough material has been gathered, the soldiers bring it inside the tent. The tent floor is inspected first. Is the ground level? Are there rocks or roots that need to be removed? Small rocks are picked up and tossed outside. Larger rocks that cannot be moved are noted. The soldiers will avoid placing their bodies directly on those spots. Roots are more difficult. If a root protrudes above the surface, it can be cut or scraped down. If it is buried, it is simply avoided. The gathered material is spread across the tent floor. The soldiers work from the edges toward the centre, building an even layer. The thickness varies depending on how much material is available. In ideal conditions, the layer might be 10 or 15 centimetres thick. In scarce conditions, it might be only a few centimetres. Even a thin layer provides some benefit. Any barrier between the body and the frozen ground reduces heat loss. The soldiers know this. They do not expect comfort. They are aiming for survivability. The material is distributed to prioritise the sleeping area. The centre of the tent, where the men will lie, receives the thickest coverage. The edges, where equipment is stored, receive less. This allocation reflects practical priorities. Equipment does not need insulation. Men do. Once the layer is in place, the soldiers test it. They press down with their hands, checking for thin spots or gaps. If the ground can be felt through the material, more is added. The goal is continuous coverage with no direct contact between body and earth. In some cases, the soldiers use their wool cloaks as the bottom layer, placing them directly on the ground. The straw or pine boughs are then placed on top of the cloaks. This creates a two-layer insulation system. The wool provides a base barrier. The vegetation provides additional thickness. When the soldiers lie down, their combined weight compresses the vegetation. The thick layer becomes thinner, but it does not disappear. The compressed material still contains air pockets. It still resists heat transfer. During the night, the insulation degrades slightly. Moisture from the ground condenses on the bottom of the vegetation layer. The material becomes damp. Damp insulation is less effective than dry insulation. Heat transfer increases, but even degraded insulation is better than none. The soldiers do not expect the bedding to remain perfectly dry. They accept that it will become damp. The important thing is that it continues to function well enough to prevent dangerous heat loss. In the morning, the soldiers rise and shake out the bedding material. Damp straw is left to dry if time permits. Pine boughs are discarded. The soldiers do not carry bedding materials from camp to camp. The weight would be prohibitive. Each night, new materials must be gathered. This nightly routine of gathering and preparing bedding is labour-intensive. The soldiers are already tired from the day's march. Spending additional time and energy on bedding preparation is burdensome, but it is necessary. A soldier who skips this step and lies directly on the frozen ground will not sleep well. He will wake frequently, disturbed by the cold. He will rise in the morning exhausted, his body drained by the constant effort to stay warm. Over days and weeks, this cumulative exhaustion reduces his effectiveness. The soldier who takes the time to prepare the ground properly sleeps better. Not comfortably, but better. He wakes more rested. He's able to march the next day without the added burden of the cold-induced fatigue. The difference between these two outcomes is the difference between a functional soldier and a struggling one. The army depends on functional soldiers. Therefore, the army expects soldiers to prepare their sleeping area properly. This expectation is enforced informally. Veterans watch recruits. If a recruit is lazy, failing to gather adequate bedding, the veteran corrects him. Not harshly, but firmly. The lesson is simple. Take care of yourself or you will not survive. The recruits learn. They observe the veterans' methods. They see that the veterans always gather bedding materials no matter how tired they are. The recruits imitate this behaviour. Over time it becomes automatic. The preparation of the ground is one element in a larger system of cold weather survival. The rampart blocks the wind. The tent provides shelter. The wool clothing insulates the body, the shared body heat raises the air temperature, and the prepared ground prevents heat from being drained away into the frozen earth. Each element supports the others. Remove any one element and the system becomes less effective. The soldiers might still survive, but the margin of safety decreases. The risk of cold-related injury increases. The Romans did not design this system through scientific analysis. They developed it through trial and error, through the accumulated experience of thousands of campaigns in cold climates. Each generation of soldiers learned from the previous generation. Knowledge was passed down through observation and imitation. The result was a practical, robust system that worked. It was not perfect. Soldiers still suffered from the cold, but the system was good enough to allow the army to function in environments that would have been lethal without it. The ground beneath the tent, prepared with straw or pine boughs or whatever materials were available, was the foundation of that system. It was unglamorous work, performed in the fading light of evening by exhausted men, but it was essential. And so, night after night, the soldiers gathered their materials, reared them across the tent floor and lay down on the insulated surface. The frozen earth remained below them, still cold, still dangerous. But now there was a barrier, and that barrier, thin as it was, made survival possible. The final arrangement inside the tent is dictated by necessity. 8 men must fit into a space that offers each barely more than 1 square metre. The only viable configuration is side by side, lying in parallel, bodies pressed together. The soldiers enter the tent one by one, crouching to clear the low entrance. They move to their customary positions. The arrangement is rarely discussed. Over time, each contubernium develops an informal pattern. The same men sleep in the same relative positions each night. This consistency reduces confusion. In the darkness of the tent, where no light penetrates, the soldiers navigate by memory and touch. Knowing that the man to your left is always the same person provides orientation. You know his size, his breathing pattern, his habits. This familiarity makes the close quarters more tolerable. The soldiers remove their outer layers if they are wet. Damp wool is uncomfortable and less insulating than dry wool. But the soldiers do not undress completely. They keep their tunics on. The tunic provides a layer between skin and cloak, absorbs sweat, and preserves some modesty in the cramped conditions. Boots are loosened but not removed. A boot that is removed in freezing temperatures may be frozen solid by morning, impossible to put back on. The soldiers have learned this lesson. They loosen the laces to improve circulation but leave the boots on their feet. The soldiers lie on their sides. Lying on the back would require more space. Lying on the stomach is uncomfortable for extended periods. Side lying is the most efficient position for maximising the number of bodies in a limited area. They face the same direction. 8 men lying in alternating directions would create a chaotic tangle of limbs. Facing the same way, the men nest together. Each body curves slightly, fitting into the space created by the next. The shoulders touch. The hips press together. The legs overlap. One man's knees rest against the back of the next man's thighs. The feet tangle together at the end of the row. There is no gap between bodies, no empty space. The soldiers form a continuous line of human warmth. This physical intimacy is profound. In civilian life, such closeness would be reserved for family or lovers, but in the tent, it is simply the condition of survival. The soldiers do not choose intimacy, they endure it. The lack of choice makes the intimacy easier to bear. There is no expectation of affection or emotional connection. The contact is purely functional, bodies generating heat, heat being shared, heat enabling sleep. The transaction is mechanical, not emotional. But over time, the constant proximity creates bonds. Not romantic, not necessarily even friendly, but bonds nonetheless. The men know each other's bodies as well as their own. They know who snores loudly, who shifts position frequently, who sleeps deeply, who wakes at the slightest sound. This knowledge is practical. If one man is restless, the others are disturbed. The contubernium has a shared interest in everyone sleeping well. If one man is too cold, shivering uncontrollably, his shivering disturbs the others and reduces the overall warmth. The group must address the problem. The solution is usually repositioning. The cold man is moved to the centre of the row, where he receives body heat from both sides. The warmest men take the end positions, where they lose heat to the outside air but buffer the colder men in the middle. This redistribution is done without complaint. It's understood that everyone benefits when everyone is warm enough to sleep. Individual discomfort is subordinated to collective survival. The heavy woolen cloaks are pulled over the row of bodies. The cloaks do not cover each man individually, they cover the group. One cloak might be spread beneath all 8 men, compressed by their weight into a thin mat. Another cloak is pulled over the top, covering shoulders, torsos and legs. If only 2 cloaks are available, the coverage is incomplete. Feet might be exposed, shoulders might extend beyond the edge. The soldiers tuck themselves together more tightly, reducing their collective footprint to fit beneath the limited covering. The weight of the wool is substantial. The cloak presses down on the bodies beneath it. This pressure is not uncomfortable. It is reassuring. The weight confirms that the barrier is in place. The heat is being trapped. Beneath the cloak, the air begins to warm. Not quickly, not dramatically, but perceptibly. The bodies generate heat continuously through metabolic processes. This heat radiates outward, warming the air in the immediate vicinity. Normally, this heat would dissipate into the surrounding environment, but beneath the heavy wool the heat accumulates. The temperature rises a few degrees. The change is subtle but significant. The soldiers can feel it. The air against their skin is no longer as biting. The wool against their shoulders is no longer as cold. This warmth is fragile. Any gap in the cloak allows it to escape. The soldiers are careful not to disrupt the covering. Movement is minimized. If someone must shift position, he does so slowly, carefully, ensuring the cloak remains in place. Sleep does not come easily. The ground is hard despite the insulation. The cold is still present, merely reduced, not eliminated. The proximity of other bodies is strange, even after months of repetition. The soldiers lie awake, waiting for exhaustion to overcome discomfort. Breathing is audible. 8 men breathing in a confined space create a rhythmic sound. Inhalation, exhalation. The sound is steady, almost hypnotic. Some soldiers find it soothing, others find it intrusive, but all become accustomed to it. The breathing also contributes to the warming process. Exhaled breath contains moisture and heat. This warm, moist air is trapped beneath the cloak, adding to the thermal envelope. The air becomes humid, almost thick. It smells of sweat, wool, and the earthy scent of the vegetation beneath the men. The smell is not that pleasant, but it is familiar. The soldiers associate it with rest, with safety, with the end of the day's labour. In a strange way, the smell becomes comforting. During the night, the men shift occasionally. A shoulder becomes sore from prolonged pressure. A leg goes numb. The man shifts slightly, adjusting his position. This movement disturbs the men on either side. They shift in response, accommodating the change. The adjustment ripples through the line. If one man needs to leave the tent, to relieve himself, to check on equipment, to respond to an alarm, the disruption is significant. He must extricate himself from the tangle of bodies. The cloak must be lifted. Cold air rushes in. The other men are exposed briefly to the full force of the night's cold. They grumble but do not complain loudly. Bodily needs are universal. Everyone understands. The man leaves. The others pull the cloak tight again, closing the gap he left. They wait for him to return. When he returns, he must navigate back to his position in total darkness. He feels his way, touching shoulders, identifying positions by shape and size. He slides back into place. The cloak is adjusted. The warmth begins to rebuild. This process might happen once or twice during the night. Each time the disruption sets back the warming process. The soldiers accept it. The alternative, attempting to suppress bodily functions for the entire night, would be worse. As the hours pass, the soldiers drift in and out of sleep. True, deep sleep is rare. The conditions are too uncomfortable, but they achieve a kind of rest, a state somewhere between waking and sleeping. The body recovers, if not fully. The shared warmth is the key. Without it, the soldiers would be fighting the cold all night, muscles tensed, body burning energy to generate heat. But with the collective warmth, the struggle eases. The body can relax slightly. Energy is conserved. In the deepest part of the night, when the temperature outside drops to its lowest point, the soldiers are at their most vulnerable. The heat generated by 8 bodies is barely enough to maintain a survivable temperature inside the tent. The margin is thin, but the margin holds. The soldiers endure, shoulder pressed to shoulder, breathing the same humid air, sharing the same rough wool covering. They survive the coldest hours. And when the first light of dawn begins to filter through the leather, when the camp stirs and the watch changes for the final time, the soldiers are still there, still alive, ready to face another day. The impulse to light a fire inside the tent is powerful. The soldiers are cold. A brazier filled with glowing coals would provide immediate warmth. The solution seems obvious, simple, irresistible, but it is forbidden. The prohibition is not written in formal regulations. It is not enforced by officers making inspections. It is enforced by survival. The soldiers know, through experience and through stories passed down from veterans, that a fire inside the tent is deadly. The danger is invisible. The fire itself poses no obvious threat. The flames are small, contained in a metal brazier. The heat is welcome. But the fire produces something the soldiers cannot see, cannot smell, cannot taste. Gas that kills quietly. The Romans do not understand carbon monoxide in scientific terms. They do not know about incomplete combustion, hemoglobin binding, or oxygen displacement. But they understand the result. Men who sleep near burning charcoal in enclosed spaces do not wake up. The understanding comes from observation. At some point in the army's history, soldiers attempted to warm their tents with braziers. Some of those soldiers died during the night. Others woke feeling sick, nauseous, dizzy, weak. The connection between the enclosed fire and the deaths was recognized. The conclusion was simple. Do not burn fuel inside the tent. This prohibition is reinforced by the physical reality of the Papilio. The tent is small. 9 square meters of floor space, a low ceiling, minimal ventilation. The entrance flap, when tied shut, creates a nearly sealed environment. A brazier burning inside this space would consume the available oxygen rapidly. The combustion would become incomplete. Carbon monoxide would accumulate. The concentration would reach lethal levels within hours. The soldiers sleeping inside would be unaware. Carbon monoxide does not cause immediate symptoms. There is no coughing, no burning sensation. The victims simply feel tired. They fall asleep. They do not wake. In a larger tent with better ventilation, the risk would be lower. The carbon monoxide would be diluted by fresh air. The concentration might remain below lethal levels. But in the standard legionary tent shared by 8 men, the margin of safety does not exist. The discipline to refuse the fire is difficult. The soldiers are freezing. They see officers in larger tents using braziers safely. They know that warmth is available, but they also know that the warmth would kill them, so they endure the cold. They rely on their wool layers, their shared body heat, and the insulation provided by the tent and the prepared ground. These methods are slower, less dramatic, but they are safe. The temptation is strongest on the coldest nights. When the temperature drops far below freezing and the wind howls across the rampart, the soldiers lie shivering beneath their cloaks. In those moments, the idea of a small fire is almost unbearable to resist. But resistance is enforced collectively. If one man suggests bringing in a brazier, the others refuse. The contubernium operates by consensus in matters of survival. No single soldier can endanger the others. The group overrides individual impulse. This collective discipline is one of the Roman army's strengths. Individual soldiers might make poor decisions driven by discomfort or desperation. But the group, informed by shared knowledge and mutual dependence, makes better decisions. The brazier remains outside the tent. Small fires burn in designated areas of the camp, supervised and controlled. The soldiers warm themselves briefly at these fires during the evening. They cook their meals, they dry their wet clothing as much as possible. But when they enter the tent to sleep, they leave the fire behind. The distinction between officers and common soldiers in this matter is stark. Centurions occupy tents similar in dimension to the Papilio, but house only 1 man instead of 8. The tent's volume is the same, but the number of occupants is reduced. Even so, a centurion's tent is not large enough to safely use a brazier for extended periods. The ventilation is insufficient. The risk of carbon monoxide poisoning remains. Higher-ranking officers, however, have larger tents. A commander's tent might be 3 to 4 meters tall and significantly wider. The volume is much greater. A brazier in such a tent would produce carbon monoxide, but the larger air volume would dilute it. The concentration would remain below dangerous levels. especially if the tent had ventilation openings. These officers could use braziers safely under supervision. A servant or attendant would maintain the fire, ensuring it did not burn too hot or produce excessive smoke. The tent flaps would be adjusted to allow some air circulation. The officer would sleep in relative warmth. The common soldiers, watching this, understand the hierarchy. Warmth correlates with rank. This is not resented as much as it might be. The soldiers recognise that the difference is structural, not arbitrary. The larger tent makes the brazier safe. The smaller tent does not. What would be resented is if officers ordered common soldiers to use braziers in their small tents, ignoring the danger. But this does not happen. The officers, many of whom have served as common soldiers themselves, understand the limitations. The prohibition on fires in the Papilio is respected. The historical record contains occasional references to soldiers suffering from exposure to fumes. One account describes the Emperor Julian, while travelling, activating a heating system in his temporary quarters. The system used heated air channeled through flues beneath the floor. Julian began to feel ill, nausea, headache, and had the system shut down. This account confirms that the Romans recognised the danger of enclosed combustion, even if they did not understand the precise mechanism. Julian's symptoms are consistent with mild carbon monoxide exposure. The fact that he ordered the heating stopped suggests an awareness that the fumes were harmful. The common soldiers do not have heated floors or sophisticated ventilation. They have wool, leather, and discipline. The discipline to refuse the quick solution. The discipline to endure discomfort in order to survive. This discipline is tested every night. The cold presses in, the soldiers lie shivering. The brazier, glowing just outside the tent, is visible through the small gap in the entrance flap. The warmth is tantalizingly close, but the flap remains tied. The brazier stays outside. The soldiers pull their cloaks tighter, press closer together, and wait for their collective body heat to slowly raise the temperature inside the tent. It takes time, an hour, sometimes longer, but gradually the warmth builds. The air beneath the wool becomes less frigid. The shivering decreases. Sleep becomes possible. The soldiers have chosen survival over comfort. They have accepted that the cold is tolerable, while the fire is not. This choice, repeated across thousands of tents, across hundreds of campaigns, is one of the quiet acts of courage that sustains the Roman army on the winter frontier. When morning comes and the soldiers emerge from their tents, they are cold, stiff, and tired. But they are alive. The fire that would have warmed them would also have killed them. The discipline to refuse it has saved their lives. And so, night after night, the tents remain dark. No flames, no coals, only wool, breath, and shared warmth. It is not comfortable, but it is enough. The Roman military camp at night reveals its hierarchy through warmth. The distribution of thermal comfort follows the chain of command with precise gradation. At the bottom, 8 legionaries share a low-leather tent with no internal heating. At the top, the commander rests in a spacious pavilion where a brazier burns safely under supervision. The centurion occupies a position between these extremes. His tent is similar in footprint to the Papilio, but houses only one man. The dimensions are roughly 3 meters by 3 meters, with a slightly higher ceiling reaching perhaps 2.4 meters at the ridge. This additional height provides more internal volume. The tent contains approximately 20 cubic meters of air instead of 15. More importantly, the centurion does not share this space with 7 other men. He sleeps alone. The increased volume and reduced occupancy create different thermal dynamics. One body generates less heat than 8 bodies, but one body also consumes less oxygen. The air exchange requirements are lower. The tent can be sealed more tightly, without creating dangerous carbon dioxide buildup. A centurion could, theoretically, use a small brazier in his tent with some degree of safety. The larger volume would dilute the carbon monoxide. The lower oxygen consumption would slow the accumulation of dangerous gases, but the margin of safety would still be narrow. Most centurions do not take this risk. They understand that even with greater volume, a brazier in a tent of this size is dangerous. They sleep without internal fire, relying on the same methods as their men: wool layers, heavy cloaks, and preparation of the ground. The difference is that the centurion has more cloaks, more blankets, better quality wool. He does not need to share these resources. His equipment is his own. Where 8 legionaries might have 5 or 6 serviceable cloaks between them, the centurion has 3 or 4 for himself alone. This abundance provides better insulation. The centurion can layer cloaks both beneath and above himself. He can wrap himself completely. The thermal envelope he creates is more effective than what is possible in the communal arrangement of the contubernium. The centurion also has access to better bedding materials. While the common soldiers gather straw or pine boughs, the centurion might have a straw-filled sack, a primitive mattress. This provides superior insulation from the frozen ground and some cushioning against the hardness. These advantages do not make the centurion comfortable. His tent is still cold, the ground is still hard, the night is still long, but his experience of the cold is measurably less severe than that of the soldiers under his command. The centurion's tent also offers something the Papilio does not: privacy. He does not sleep pressed against 7 other men. He does not hear their breathing, smell their sweat, feel their movements. He can arrange his sleeping space as he prefers. He can move during the night without disturbing others. This privacy is a privilege of rank. It acknowledges the centurion's responsibilities and status, but it also creates isolation. The centurion sleeps alone while his men sleep in collective warmth. On the coldest nights, the centurion might actually be colder than his soldiers, despite his superior equipment. 8 bodies generate more heat than 1 body. The soldiers, despite their cramped conditions and shared resources, benefit from a collective warmth that the centurion cannot replicate alone. The centurion has chosen or has been assigned solitude over shared heat. Higher up the command structure, the differences become more pronounced. The tribunes and legates occupy tents that are significantly larger. A tribune's tent might be 4 meters by 4 meters with a ceiling height of 3 meters or more. The volume is double or triple that of a centurion's tent. These tents are divided into sections: one area for sleeping, another for working, a third for storage. The internal organization resembles a small house rather than a simple shelter. Wooden furniture is sometimes brought in: tables, chairs, a proper bed frame. With this much internal volume and proper ventilation design, a brazier becomes safe. The tent can be equipped with a vent hole at the peak of the roof, allowing smoke and gases to escape. Fresh air enters through controlled openings near the ground. The circulation prevents dangerous accumulation of carbon monoxide. A servant maintains the brazier, adding fuel, adjusting the airflow, monitoring the tent's interior. The servant ensures the fire does not produce excessive smoke or consume too much oxygen. The tribune sleeps in genuine warmth, warmer than he would be in many civilian buildings of the period. The commander's tent is larger still. It serves not only as sleeping quarters but as headquarters. The tent might be 6 meters wide and equally long, with a ceiling high enough for a tall man to stand comfortably anywhere inside. The structure requires multiple poles and extensive guying to remain strong. Inside this tent, military business is conducted. Officers gather for briefings, maps are consulted, orders are written. The space must be warm enough for these activities. A brazier is essential, not merely for comfort, but for operational necessity. Ink freezes, fingers become too numb to write, decisions are harder to make when everyone is shivering. The commander's brazier burns throughout the evening and into the night. The tent is kept at a temperature that would seem warm to the legionaries outside. Not hot, but above freezing. Warm enough that wet clothing can dry. Warm enough that the cold is merely background, not a constant assault. This warmth is a function of volume, ventilation, and resources. The commander has a tendency to manage the fire. He has access to ample fuel. His tent is designed with thermal management in mind. The same fire that would kill a legionary in a Papilio keeps the commander safe and functional. The gradation of warmth creates a visible hierarchy. Walking through the camp at night, the differences are apparent. The rows of small dark Papilios emit no light, no heat. The centurion's tents are similarly dark, but the officers' tents glow faintly from within, the light of braziers filtering through the leather. The legionaries see this. They understand what it means. Rank brings privilege. Privilege includes warmth. This is accepted as natural. The commander must remain functional. His decisions affect the entire army. If keeping him warm ensures better decisions, the warmth is justified. but the acceptance is not unlimited. If the officers were warm while the soldiers froze unnecessarily, resentment would grow. The Roman military system mitigates this by ensuring that officers share most of the soldiers' hardships. They march with the army, they eat similar food, they endure the same weather. The officers are warmer at night, but not by an order of magnitude. They are more comfortable, but not luxurious. The gap is real, but not vast. This moderation preserves the bond between officers and men. The system also includes an element of aspiration. A legionary can, through merit and time, become a centurion. The centurion can rise to higher ranks. The warmth of the officer's tents is not permanently inaccessible. It is something to be earned through service. This creates a practical incentive structure. Endure the cold now. Rise through the ranks. Achieve the privilege of a warmer tent. The future possibility of comfort makes present discomfort more bearable. But for most soldiers, the rise through ranks is slow or never happens. They will spend years, perhaps their entire service, sleeping in the papilio with 7 other men. No internal fire, only wool and shared warmth. They accept this because they must. The alternative is to leave the army, which is often not a viable option. Military service provides regular pay, food and structure. For many men it is the best life available, and so the hierarchy of warmth persists. The commander sleeps warm, the centurion sleeps cold but alone, the legionaries sleep colder but together. Each level of the hierarchy has its compensations and deprivations. The structure is logical. It reflects the different needs and responsibilities of each rank. But it also reinforces the distance between officers and men. The commander, warm in his tent, does not experience the same night as the legionaries. He cannot fully know what they endure. This experiential gap is bridged partially by memory. Many officers have risen from the ranks. They remember sleeping in the papilio. They remember the cold. This memory informs their decisions. They know what they are asking of their men because they have done it themselves. But memory fades. Warm nights dull the recollection of cold ones. Officers who have been warm for years may forget the precise quality of the suffering. This creates a risk of disconnect, of orders that do not account for the soldier's actual condition. Good officers resist this drift. They periodically inspect the soldiers' quarters. They listen to complaints. They maintain awareness of the gap between their experience and that of the men they command. This awareness is essential for effective leadership. The warmth gradient in the Roman camp is not incidental. It is designed. It motivates, rewards, and sustains. It acknowledges that not all men can be equally warm, but it ensures that warmth is distributed according to function and merit. And at the bottom of the gradient, in the small leather tents scattered across the camp, the legionaries huddle together, generating through collective effort the warmth that rank and resources provide to those above them. As the soldiers settle into sleep, the camp does not fall silent. The darkness brings its own rhythms, sounds that structure the night and provide reassurance that the camp remains secure. The most constant sound is the watch. 4 times during the night the guard changes. The Romans divide the night into 4 vigilia, each approximately 3 hours long. At the end of each watch, new sentries replace the old. This rotation ensures that no man stands guard for too long, becoming drowsy or ineffective. The changing of the watch is not done quietly. It is a deliberate, audible process. The new sentries report to their posts. The old sentries are relieved. The exchange involves verbal confirmation. Passwords are spoken. Positions are identified. The process follows a ritual that ensures continuity and prevents confusion. The sounds of this exchange carry through the camp. Footsteps on the compacted earth, the low murmur of voices, the clank of equipment as sentries adjust their positions. These sounds are familiar. The soldiers sleeping in their tents recognize them automatically. The recognition is reassuring. The watch is changing. The defences remain active. Order persists. The camp is secure. Between the watch changes, the sentries patrol. They walk along the Via Sagalaris, the road that runs just inside the rampart, circling the entire perimeter. Their footsteps are rhythmic, steady. The sound of boots striking the frozen ground creates a predictable pattern. This pattern becomes background noise. It is always present, therefore not alarming. The sleeping soldiers hear the footsteps without fully waking. The sound confirms that the sentries are alert, moving, performing their duty. If the footsteps stopped, the silence would be noticeable. The absence of sound would wake soldiers who have become attuned to its presence. The stopping of patrols would indicate a problem, but as long as the footsteps continue, regular and unhurried, the camp is functioning as it should. The sentries also call out periodically. Short phrases, confirmations, all quiet. Nothing sighted. These calls are directed to other sentries, to officers, to anyone listening. They serve multiple purposes. They confirm that the sentry is awake and alert. They communicate the current status, and they provide audible evidence of the watch's continuity. For the soldiers in the tents, these calls are part of the night's texture. They punctuate the darkness. They mark the passage of time. A soldier waking briefly can estimate the hour by the number of watch changes he has heard. The calls also have a psychological function. They transform the darkness from an unknown threat into a known, managed situation. The night is not empty. It is occupied by Roman sentries, armed and vigilant. The wilderness outside the rampart is monitored. Anything approaching will be detected. This sense of monitored security makes rest possible. A soldier lying in the dark cannot see beyond the tent walls. He cannot know what is happening outside, but he can hear the watch, and hearing the watch, he can trust that he is protected. The wind also creates sound. It moves over the rampart, through the palisade, around the tent ropes. The sound varies with the wind's strength. A gentle breeze produces a soft rustling. A strong wind creates a louder, more insistent noise. The tent leather itself makes sound. When the wind presses against it, the leather flexes slightly. The fibres creak, the seams shift. These sounds are subtle but present. The soldiers learn to distinguish between normal tent sounds and sounds that indicate a problem. A loud crack might mean a guy rope has snapped. A flapping noise might indicate that the entrance flap has come loose. These sounds require attention. A soldier will wake, identify the problem, and correct it. But most tent sounds are harmless. They are simply the structure responding to the wind. Rain, when it falls, creates a distinct sound pattern. The drops strike the leather with a soft, irregular percussion. Light rain produces a gentle pattering. Heavy rain creates a continuous drumming. The sound is loud inside the tent, magnified by the proximity of the leather overhead. Rain sounds are not pleasant, but they are not alarming. They indicate that the soldiers will wake to wet conditions, but they do not threaten immediate danger. The tent, if properly maintained, will shed most of the water. Some leakage is inevitable, but catastrophic flooding is rare. Snow is quieter. It falls silently, accumulating on the tent without announcing its presence. The soldiers cannot hear a snow falling. They only discover it in the morning when they emerge and see the white layer covering everything. But snow's presence can be inferred from other sounds, the muffling of footsteps, the softening of wind noise. Snow absorbs sound, creating a distinctive quiet. Experienced soldiers recognize this acoustic signature and know that snow is falling even though they cannot hear it directly. Inside the tent, the soldiers themselves create sound. Breathing is the most constant. 8 men breathing in rhythm in and out produce a low, continuous susurration. The sound is almost hypnotic. It marks the living presence of the contubernium. Changes in breathing pattern are noticeable. If a man's breathing becomes rapid or laboured, it indicates distress. Illness, pain, or extreme cold can alter breathing. The other members of the contubernium, even while sleeping, may notice the change and wait to check on their companion. Snoring is common. Some men snore loudly. This can be disruptive, making sleep difficult for those nearby. But complaints are rare. Snoring cannot be controlled. The snorer is not deliberately disturbing the others. It is simply endured. Occasionally a soldier talks in his sleep. Fragments of sentences, names, orders. The words are usually unintelligible, but the sound is recognizable. The others ignore it unless the speaker becomes agitated, thrashing or crying out. Then someone might wake him, ending whatever dream has disturbed his rest. Movement creates sound. The rustle of wool as a soldier shifts position, the scrape of a boot against the ground, the creak of leather equipment. These sounds are constant at a low level. The soldiers move periodically during the night. adjusting for comfort, relieving pressure points. Larger movements are rarer. A soldier sitting up, standing, moving toward the entrance. These actions create more substantial noise and often wake the nearby men. If the movement is purposeful, someone leaving to relieve himself, the others accept the disturbance. If the movement is random or agitated, it prompts questions. Are you well? What's wrong? The collective nature of the sleeping arrangement means that disturbances are shared. One man's restlessness affects all 8. This creates social pressure to remain still to minimize disruption, but it also means that problems are noticed quickly. A soldier who is too cold, too sick, or too anxious to sleep will be identified and, if possible, helped. Outside the tent, the camp contains other sounds. The sentry's activities have already been mentioned. But there are also animals. The mules and horses tethered in their designated areas make noise periodically. A mule might bray, startled by something. A horse might whinny, disturbed in its rest. These sounds are recognizable and not alarming. They are part of the camp's normal acoustic environment. The soldiers distinguish between the sound of their own animals and the sounds that might indicate intruders, unfamiliar animals, human movement in unexpected locations. Dogs sometimes accompany the army, not as official military assets, but as informal companions. A soldier might adopt a stray dog, feeding it scraps, allowing it to sleep near his tent. These dogs bark occasionally, alerting to perceived threats. The barking is usually ignored unless it becomes persistent or multiple dogs join in. The fires burning in the camp create their own sounds. The crackle of wood, the pop of sap igniting. These sounds are comforting. They indicate warmth, light, and controlled human activity. As the night progresses and the fires burn down to embers, these sounds diminish. By the deepest part of the night, the 3rd or 4th watch, the camp is at its quietest. Most fires have died. The soldiers are deeply asleep. Only the sentries remain active, their footsteps and occasional calls the primary sounds. This deep night quiet has a quality different from the earlier evening. It is a profound stillness, broken only by wind, breathing, and the measured tread of the watch. The camp has settled into itself. The day's activity is long past. The morning's activity is still distant. In this stillness, the soldiers rest most deeply. Their bodies, exhausted from the day's labour, surrender to sleep despite the discomfort. The cold is still present. The ground is still hard. But fatigue overcomes discomfort, and through it all, the watch continues. The sentries pace their routes. They call their confirmations. They ensure that the camp's security holds through the darkest, coldest hours. For the soldiers in the tents, these sounds are the boundary between consciousness and sleep. Hearing the watch, they relax into rest. The sounds confirm that order persists, that discipline holds, that the Roman system, tested by cold and darkness, continues to function. The night is long, but it is not chaotic. It is structured by sound, measured by the watch, made bearable by the knowledge that vigilance is maintained. And when the final watch begins, the soldiers know that dawn is approaching. The sounds of the camp will change. Movement will increase, voices will rise, the night will end. But until then, the sounds of the watch remain. Steady, predictable, reassuring.